Everyone, and thank you for being here. My name is Andrea Tumino, and I'm working at SEOA on SURPASS project. Together with our sister project, Redondo, Repurpose and Estella, we have decided to organize this workshop to present you our methodologies implementing the SSBD approach for our R&D R&D processes. We are still waiting until 8:50, so let's say 1 minute before starting. In the meantime, I would suggest to those that are already present to either use the QR code that you can see there, or go on menti.com and enter the following code. We will be starting soon. As a reminder, today, the agenda today will be start with Lia Hernandez, representing the IRIS project, who will give us an overview of the SSBD framework of the JRC, and then each project will follow one after the other, starting from SURPASS, then Redondo, Repurpose, and Estella. Between each project, there will be a 10-minute break, and this is to give, on the one hand, to give everyone time to take a coffee, or simply to simply to put our brain in pause for a few minutes and keep the while keeping the interest high. So I think there are already how many people are on Menti? Okay, there are 10 people on Menti. We are 52, so okay, now there are even less people on Menti. So when at the end of the talk of each project, there will be time for question. However, we cannot give speakers right to everyone, but if you notice on the bottom right of your screen, close to the chat button, there is the questions button. There you can add your question, and other people with similar question or the same question can eventually vote on that question, and that will help us prioritizing. So please do not use the chat to pose your questions to the speakers. Otherwise, we might not read them, as they might be lost in the chat among the other messages. So, okay, it seems that the situation on Menti has leveled off around 11 participants.
We have 52.
We are 52. Yeah. So
on live stream.
Yes. So I will suggest to all people to please go on Menti. We have a few slides for you. They are interactive slides for you that allow us taking information about your background on or what you expect from this workshop. Okay, 14, slightly increasing. Okay, 16 people. Okay. people on Menti keep increasing and decreasing. I'll say that anyway, in order to leave everyone the time to reply to the question, I will say that as soon as we reach at least 20 participants, we will start on Menti. We are almost there. We are at 18. There will be time for the others to join, and eventually they will have skipped a few questions. That is not a big problem. Okay, so we are 20 people. I will now. So okay, this is again a slightly bigger QR code. And the first question is basically, what is your country of origins or that of your institution? Okay. We are, well, 20 people have replied, of over 20, so there is the majority, if not everyone, comes from 22 responses, so people are keep joining in. A big representation from all Europe. Well, that's how, as expected from European projects. Okay. More people are connecting, so let's give a few more seconds to. Okay, thank you for your replies. Now we can, oh, yes, still have people connecting. Okay. Wow. Okay, thanks. We can move now to the next question. So here, what is your background? So where do you come from in terms of exactly of your field of expertise or your studies? That is a very, very, very differentiated audience today. 28 response already.
It shows that sustainability is a cross skills area.
Yeah. Okay. 33 responses. Well, we had 33 before, so it means, well, yes, there is a lot. The background is very, very varied for this audience, with a focus on science, but there are also people with a language background or economics, architecture. So this really, as Sebastian said, this really shows how sustainability and safe and sustainable by design is actually something that is very, very, how to say, cross-platform and multidisciplinary. This is something that eventually today will come out also from hearing from our speakers. Okay, let's move to the next question. And here we would like to know what is the sector you come from. co-op between academia, and for academia we mean students, meaning PhD students, postdoc, professor, or assistants, small and medium, small companies or SMEs, large company or corporation, government or public institutes, consulting firms, NGOs, associations or fusion, or other, like if you're in communication or you're a journalist. So there is a okay, 32 respondents before we reached 38. So let's wait for a few more seconds. So there is the largest representation is from academia, but SMEs and public institutions as well have a big representation. Okay, thank you all. Let's move to the other question. So, what is your sector of expertise here? Okay, sustainability assessment is already, we have a vote, or the energy department, environmental measurements. Okay. $31, and we are now at $33, $34. Someone from the energy sector is also here among us. $35 respondent. We can move now. Thank you very much. Let's move to the next slide. So, do you belong to any Horizon Europe or Horizon 2020 project? And if so, please reply with the name of the project. Otherwise, you can write no. Okay. We have 36. We can leave actually this slide open. We will show again the QR code later, and I invite you not to close the Mentimeter, as later we will have again other questions for you. So that being said, I will leave the floor to Lia Hernandez, representing here both the IRIS project and SURPASS, to give us an overview of the SSBD framework published by the JRC at the beginning of this year. Lia, are you there?
Yes, let me see. Can you see my slides?
Yes.
You can see them? Okay, then I'll start So thank you very much. Good morning, everybody. So today, as I said, we're representing both SURPASS and a bit of IRIS as well. But the goal of my presentation really is to give you some background on safe and sustainable by design, just to make sure that remind everybody what the framework is from the Commission, but also to give you an update on the transitioning policy landscape, because a lot has happened in the last year. And I think it's important that we recognize how the framework has also a lot of regulatory implications and how it can prepare us for regulation.
Ilia, sorry, it's that we cannot see your slide.
Oh.
There is a message saying logon has timed out due to inactivity.
Okay, hold on. Let me try again. Another screen. Okay, sorry about that. Okay, share screen, window. Oh, here, I think it's this one. Calendar, share, Chrome tab. Gives me different. I hope I can share. Hold on. I don't know if you can see it now.
No,
it's not. It just gives me two options, and I can't access the other one. Okay.
You share the live storm screen.
Hold on. No, that's not what I wanted to do. It only gives me two options. Let me try the other, the window. This window and this one.
Your calendar.
This is your calendar. So when you share,
it doesn't allow me to share. Can I send you my presentation, Simon? Sorry, I don't think it's on there.
You have three options, and you can either select one window, or you can select the one all on the right is the full screen.
Okay, let me try entire screen. And now?
Okay, now it's perfect. We see your screen.
Okay, so I'll just to go back. Okay, so I think I want to start with the policy context. I think it's important to know where the safe and sustainable by design came from. So first I started with the Green Deal, where in Europe we decided to have these goals of zero pollution, climate neutrality, and circular economy. And then this led to the chemical strategy for sustainability, where safe and sustainable by design really is central, and mainly to phase out the most harmful substances. But then there's also this the chemical strategy for sustainability action plan, where we are now in this process with the RTD and the Commission and JRC in the development of SSBD criteria for chemicals. So as you see, this started off with the first report on an overview of methods, frameworks, and different tools for safety and sustainability. This is the first report from the JRC. The second was the framework itself that they published. And at the end of last year, there was a recommendation that communicating the establishment of the sort of SSBD chemicals and materials. And this year, we had the report of lessons learned from 3 different case studies that were applying the framework. So as you can see, this is the real context that is a very important part of the chemical strategy for sustainability, and that we are now in this testing phase for the framework. One thing that I want to mention in this transitioning policy landscape is that in the chemical strategy for sustainability and in the zero pollution action plan, we really have this reversing of the pyramid of action and prioritization of approaches. So really, we are no longer interested in eliminating and remediating or minimizing and controlling, but we are in this phase of prevention. And that's where SSBD really comes from. It's a different mindset, and it wants to encourage and promote zero pollution, production processes, safe and sustainable products and services by design, as well as innovative tools, technologies, and behavioral change. So this change of mindset and prevention are really key to SSBD. From a working description perspective, this is how in the chemical strategy and also in the JRC report, the Commission has defined safe and sustainable by design. It's a pre-market approach to chemicals that focuses on providing a function or a service while avoiding volumes and chemical properties that may be harmful to human health or the environment, and in particular groups of chemicals likely to be ecotoxic, persistent, bioaccumulative, or mobile. When it comes to sustainability, really it's about minimizing the environmental footprint of chemicals, in particular on climate change, resource use, ecosystems, and biodiversity, and using life cycle perspective. So this is sort of the working description for SSBD. But what does SSBD or by design really mean? And I think I want to really have this clarity that a safety assessment and a sustainability assessment is not by design. So what by design really means is that you do a two-step iterative, well, it's a two-step process, but you do this iteratively. So on the top here, you have the life cycle. So you start from materials and you end into waste. And in here, the second, you really have the Cooper stage gate model, which is just a model that depicts the innovation process. And the idea, what we see that the current situation that most often in this really early stage of the innovation, the chemical and product development is very functionality based. And later on, when you have a prototype, then you're going to start thinking, oh, what a little bit of safety, sustainability, how to get the product or chemical on the market. And I think where we want to go is this sort of iterative integration of functionality, safety, and sustainability all throughout the innovation process. So it's this iterative process of integrating in every step and every gate innovation and functionality with safety and sustainability. And I think that's what this by design. So for instance, if you have knowledge on recycling, you want to bring that knowledge, the challenges back to the design to deal with that knowledge. So if you have challenges of safety and sustainability in the production, you want to bring it back to the design. So there's solutions, so there's a communication along the entire life cycle. And I really want to highlight this iterative. So it's not something that you only do once and you're done. So it's an iterative process, whether you are producing a chemical or a material or a product. It's this iterative process that you constantly are trying to assess in every step the safety and sustainability and how that affects the functionality of the process of your material, product, or chemical. And what you see, this is a picture from the JRC report that they do see these green chemistry principles as guiding principles to have design actions and, like I said, iterative innovation. So you're iterative around the innovation, and then you have this assessment phase, which I will discuss in the next slide. So what is the SSBD framework? So the SSBD framework has two phases. The first phase is the redesign phase, and this is based on guiding principles and indicators proposed to support and design of chemicals and materials. And you can think of from material efficiency to designing for end of life. So this is sort of the first step. Right now, with the framework, we are trying to test this assessment phase, and this is where most of the discussions are happening. So I want you to also think how this framework is preparing for all the upcoming regulations that are coming, but the question is, how do we bring this to the innovation process? So the first step, it's a hierarchical. So you start first with safety, and you look at intrinsic hazard, very grounded to REACH, and COP, which is classification, labeling, and packaging. So think of when you have harmonized classification and labeling, that is really the first step. The second and third have a lot more to do with exposure, looking at occupational and consumer exposure. Again, very much grounded in REACH and using models like USTOPS model. The fourth step is the environmental sustainability. And here you can think about the PEF, the product environmental footprint, as a methodology that is used. But more important, this eco-design sustainable product regulation, which is coming up, the ESPR, which I will mention what this means. So that will be a new regulation for eco-design. And finally, the socioeconomic aspects, because I think these are sometimes overlooked. But in the regulation, there's new changes in the Corporate Sustainability Reporting Directive, the CSRD, and it will have huge implications for investments, particularly if you're a small company. So it's important that you understand that the framework is not only a way of preparing yourself for regulation, but it could also have a lot of implications on the businesses that are, if you want to stay in business in Europe. So I'm going to go through each of the assessment phases and tell you what the updates are and what things we should consider. So the first is REACH. I'm only going to focus on the step 1 on the hazard. As you know, or maybe you don't know, REACH is being now revised. There's a new revision. And what we need to consider is that there's new hazard criteria for COP for new categories. And these include the PMTs, which are persistent mobile and toxic substances, terrestrial organisms, immunotoxicity, developmental neurotoxicity, endocrine disruptors, and PBTs, persistent bioaccumulative and toxic. The other aspect you need to consider that there'll be huge restrictions on substances of concern in consumer products. That is key in the chemical strategy for sustainability. So this COP will have a lot of implications if you're in that sector. And looking at going back to the framework, you need to understand the different criteria, because I think you have 3 criteria in the framework. So this one is no SSBD. So this is the most harmful substances, the substances of very high concern. You can think of carcinogens, mutagens, reproductive toxicants, but only categories 1A and B, and also specific target organ toxicity. And again, focusing on immunotoxicity and neuro, and also PBTs and PMTs and endocrine disruptor from an environmental hazard perspective. From the H1 class, you have the H2 that is also a bit of the CMR, but the evidence is not as clear. So is the class 2 CMRs, and also the specific target organ toxicity for single exposure to, and again, endocrine disruptor. And you have the aquatic tox. And finally, so this would be sort of the yellow area for SSBD according to the framework right now. And finally, you have sort of this area of almost yellow-green, whereas other classes, you think about acute toxicity, corrosion, irritation, eye damage, and other different endpoints. So it's good to understand how the framework is linked to preparing for upcoming changes in regulation. The fourth step really is this eco-design sustainable product regulation, which is just being developed right now. And it will have key product aspects looking at durability, reliability, reusability, upgradability, repairability, maintenance, the presence of substance of concern, again, linking it back to the changes in REACH and the goals of the chemical strategy for sustainability, and then energy, resources, and recyclability and environmental impact, and then waste. The important thing here is that you need to also think about, maybe not for plastics, it is important, the Critical Raw Materials Act, and that these product aspects will lead to the digital product passport. And this idea is that for every product, there will be this digital product passport to allow for traceability. So this is really important. So I think all the criteria in the frame will be very useful as input for this digital product passport. And finally, the CSRD for the financial thing. This is extremely important for small companies. As you know, for now, it's a voluntary, you do financial reporting, but mostly for big companies, it's on a voluntarily basis. And this is until now, but starting next year, there's a transition period for big companies to have not only what they call materiality, but also non-materiality. And for this transition period for 2025, but at 2026, all small companies doing anything in Europe will have to submit financial reporting for sustainability parameters. And you can think of really stringent requirements, particularly for ESG, so environmental sustainability and governance criteria, and looking at your carbon footprint, looking at how greenhouse emissions and social aspects. So you do see that if you are looking for investments as a small company, you will have to have sustainability embedded in your corporate governance. So this framework is not only the assessment, but it's really preparing you for all the changes in the European regulatory landscape. So what are the challenges? Again, this is a slide from the Green Deal SSBD consultation that happened a couple of weeks ago. This was presented by the Commission. What are the challenges that were reported by JRC? I think none of these are new, but really integrating safety and sustainability really isn't challenging in terms of improving consistency, having clear definition, a clear system scope, and overlaps and complementarities. In terms of data, obviously availability, quality, harmonization, communication, and fair. So findable, accessible, interoperable, and reusable data. 4, methodologies and tools, the modeling, the availability of tools with data, and also model-specific application scenarios. And finally, expertise and resources, training, databases, data management. So this gives you an overview of the changes in the challenges in bringing this framework into practice. I want to give you really pay attention to this timeline, because we are now in the middle of a testing phase. That means that everybody, industry, academia, regulators, policy, we have an opportunity to provide feedback on this framework. So as you can see in the timeline, this was the first report. The framework at the end of last year was the recommendation. The case study report. We are here. I want to bring attention to a workshop that's going to happen in December, the 6th or 7th of December. One member of each institution is invited to go physically in Brussels, but there's quite a lot of space for online. So please register, find out about the feedback of the framework, and please prepare yourself for the testing phase. The Commission doesn't give you a lot of time. So you have a 6-week period to provide comments. So start thinking about how to test the framework, how to bring feedback, how to ensure this framework is actually practical and applicable, because this is the last testing phase before the criteria will be developed. And this will have consequences, I think, on what is called SSBD or not. So finally, is my last slide. We really need case studies to give feedback to the Commission. Just from our first lessons learned, and I'm sure Sebastian will present it, and even Yvonne, that from our first, what we have learned is that you really need to start with the big picture. We really look at mapping all the biggest challenges, at least in each of the value chains that we have in SURPASS. For us, organizing ourselves has been extremely important. We have now these committees for each of the case studies with interdisciplinary, from toxicologists to environmental toxicologists to socioeconomic, LCA or sustainability, and also experts in each case study. This is so important. It's that expertise that allows you to deal with the gaps in data. And it's an iterative process. So we really are taking every step, and it's iterative, but we do find that it's challenging. And the biggest challenge is functionality. It's not so easy to just change an aspect of a product. It really has to have the same functionality standards or better to be able to link it with the safety and sustainability. And I think that was my presentation. Thank you very much.
Thank you very much, Leah, for this presentation, and we managed a little bit to take some of the time that we lost at the beginning. There is a question from Elena Monteiro, but that I think that in part you gave the answer, and also the aim of the workshop will be actually to reply also to this question. I'm going to read it. If SSBD is by design, how can innovative products at design stage have reliable data on use stage impacts, such as exposure, emission? Should use trials be made? Since the product is not being used, it is being iteratively developed. So
yeah, I think it's a great question. I think right now what we see is that you in the beginning try to make estimates on the scenarios that you might have. And once you find a hotspot, then you go iterative and try to redesign it. But it is this iterative process that you need to consider the use phase. And I think when you think about use phase, I see it as an opportunity. What we see is, for instance, people looking at durability, looking at other aspects of functionality that will give you also a market incentive.
Okay.
Okay.
Very much. And well, now it is time to leave the floor to the work package leader of the work package 4 leaders of SURPASS project, Sebastian Artus and Yvonne Stahl, that will give an overview of how in Project SURPASS we aim to perform SSRBD assessments.
Integrated approach and studies. Thanks, Andrea, for these introductions. Welcome all. And to keep the time, I'll go quickly to the agenda of the SURPASS presentations. Just a few seconds. Yeah. The agenda of this presentation is cut in 4 parts. I will start with a brief overview of objective and ambition of SURPASS project, and then I will present, based on the knowledge and information provided by Leah, how we establish and construct in SURPASS project a SURPASS methodology and integrated approach. Then Yvonne from IRIVM will present you how we start from and define the cycle and development diagram, LCDD, and go to the life cycle inventory and present you the step where we are in the SURPASS project with the data collection plan. First objective and ambition of SURPASS projects. In SURPASS, we have 4 main objectives. First one is to develop safe, sustainable, and we include a new word, recyclable by design plastic system to reduce environmental impact and achieve the same performance compared to conventional materials in the 3 target sector that I will present just after. This first objective is the main topic of this presentation of the SURPASS project today, and we will focus mainly on this objective. Second objective is optimize reprocessing technology and develop some new materials in the frame of the 3 sectors to support achievement of recyclability targets, aiming for the highest potential value chain for recycled materials. The 2 last objectives will be the main outputs of the SURPASS projects. And first, we will provide and we target to provide guidance accessible to non-experts with a scoring system. And this guidance and scoring system will be integrated in a digital infrastructure. That is the 4th objective, to answer to the need of material designers, formulators, and recyclers that enable sustainable polymeric materials. Now, after these 4 objectives of SURPASS projects, I will show you briefly the 3 case studies we address in the projects and to develop safe and sustainable plastics. We address 70% of the sector of plastics with the building sector, the transport sector, and the packaging sector. And for building, we have a new recyclable by design biosources polyurethane resin with vitrimer properties, and the goal is to replace polyvinyl chloride PVC windows frame. For transport, the goal is, and it will address by Investment Society. Transport is addressed, this case study is addressed by CDTech, and the goal is to lightweight epoxy vitrimer as alternative to metal for the train structure, anticipating emerging use of non-recyclable composites. And for packaging, it's multi-nano layer films with less compatibilizer to replace current non-recyclable multi-layer films associated with a decontamination process for film reprocessing by IPC. And we will try to apply this the GRC framework presented previously by Leah on these 3 case study. And today I just will focus and give some example from the first case studies. Just to give you the main level of sustainability in the development of this product, building sector is focused on implementing vitrimerization properties. For transport, they are working on reversible and intrinsically fire retarding cooling resin and to decrease energy consumption of the process also. And on packaging, it implements a closed loop with a mechanical recycling based on critical CO2. Just a brief overview of the complementarity of partners in SURPASS project. In this row in green, you have partners involved in the development of the new products and by implementation of reprocessing and recyclability, where we have SMEs, industrials, technical center and academic researchers. And to support and help these developments of new products, we have a part of standards, policy, and regulation. This task is performed along the life of the projects. And in light green, you have the safe, sustainable, and recyclable assessment strategy with experts from toxicologists to environmental and LCA experts. And we try to answer in a holistic visions and to avoid parallel working, but to have a step of integrations. And and to help the development and integrate the sustainability during the process of the development of products to obtain the true output of this SURPASS with the digital infrastructure and the guidance. Just to illustrate, we plan to obtain a scoring-based assessments with the illustration you can have on the left, with spider diagram that assets the several pillars of the sustainability. And this type of guidance tools will be integrated in the digital infrastructure, but offering an open access and a user-friendly interface for innovators and in particular SMEs. To do this and to reach these goals, now I will present you the SURPASS methodology and how we try to have an integrated approach during the design of the new products. As Leah presented previously very briefly, it's just one slide to remind the context and to remind that proposal of SURPASS was written before the publication of the GRC framework, but we try to integrate it, and this framework comes from European Green Deal, and on the topic regarding the zero pollution ambitions, and Commission published a chemical strategy for sustainability, and one tools to answer to this strategy and reducing negative impact on human health and environment is the publication of a framework to define safe and sustainable by design criteria for chemical and materials. And you have an illustration on the right of the 5 steps of these assessments. And in the GRC framework, they define 2 steps, the redesign 5, guiding principles, and the safety and sustainability assessments. And I will try to show you and explain you how in SURPASS projects we can establish a strong interaction between these 2 steps to improve the design of these products, and we have to implement in a life cycle perspective. What does by design really mean? It's a slide also shown by Leah, but the classical and current situation in say by design classically, it's to have a chemical product development, then a step of safety sustainability with some gate and an iterative process. But the gate process can have some issues and difficulties and can be time consuming. And we try to use also the work performed by the OECD and that propose the safe and sustainable innovations approach. And we try to take in account to have an integrated approach with the safety and sustainability integrated chemical product development. To have this SURPASS integrated approach, we have to merge some different blocks. First, the design process with that follow the technology readiness level with an iterative aspects. The second block we have to take into account is to have this design process in a life cycle perspective. Then we integrate the 5 steps of the GRC assessments inside our integrated approach. And we obtain this diagram tree, and we decide to start not from the material or the chemical in SURPASS project, but to link with classical life cycle assessment, life cycle costing or design. We start from the function of the products and based on this function, we define some technical solutions related to criteria. And with this criteria, we go to the technical design developments. And as the upper part of the decision tree, at the beginning of the project, we have a large degree of freedom, but few data available. With this large degree of freedom, we can have a strong impact on sustainability development and integration of the safe and sustainability, but it's difficult to perform these assessments. Along the life of the projects, we have an increase of the data availability, but associated with a decrease of the degree of the freedom and a less impact on sustainability potential assessments. Based on this technical design, we perform GRC framework, and I go further just after. And based on these assessments and technical developments, we have a step where we evaluate performance, and we can, if we reach all the criteria, we can have an increase of the TRL level of the materials and of the technical solutions. And if not, we have a step of hotspot identifications, and we have several choices at this stage. We can identify hotspots and work on it and have some sustainable or recyclable developments and in the development of the technical solutions. Or we can stop the route of development because we cannot reach some aspect of the sustainable developments. Or we can adjust the criteria of sustainability and to do a trade-off, for example, before technical criteria and cost criteria. Here you have the general view of the technique of the SURPASS integrated approach. And just to go more deeper in the function life cycle, we start with by defining the use of a product during X years, for example, with the same property as the reference product. It could be for a Windows frame, for example, to have a polyurethane Windows frame that have the same life than a PVC Windows frame. Based on this function life, we define some technical function. Technical function could be to have noise reduction, insulation and properties, and we always introduce the recyclability step in the technical function we have to reach. We obtain some technical solution. It could be the glass, it could be the Windows frame associated to criteria, that is recycling, technical criteria, sustainable criteria, and so on. Based on this type of function in the life cycle, we have then integrate the GRC assessments in the step of the framework, where we have all technical function, hazard, exposure, environmental, cost, and social. As described by in the GRC framework, it's not a step-by-step assessments we decide to perform in SURPASS projects, but we decide to conduct all these assessments in parallel, but at several, with a tier approach at several levels. It's to avoid the gate effects to perform assessments step by step. Here you have, for example, when we address hazards, address also we can address the step 1 of the GRC framework with the hazard assessments, or during the step of the production of the product, it's the step 2 in the GRC framework, or the step 3 that focus on the application phase of the material or the products. When we address in SURPASS the exposure, we can address step 2 and step 3 of the GRC framework with the exposure during the production or during the use phase. Environmental assessment is addressed for the step 3 during the use phase, and also with the LCA during the environmental sustainability assessments. And cost is addressed also in SURPASS in step 5, and to be comprehensive, we put social, but is not included in the SURPASS projects when we wrote and we propose this project, but we include in the methodology this social aspect. Now, I just would like to illustrate the application of this global methodology on the first case study. The first case study is about bio-based polyurethane windows frame developments. And here you have a simplified view of the routes to obtain this window, the life cycle of this polyurethane windows, with the mixing of a polyol and a natural gas based. We obtain a biopolyurethane windows. Then at the end of the life cycle, we obtain a polyurethane production waste, and we have two routes for recycling, a chemical recycling, and performed by Industries, we have a mechanical recycling. For the moment, only a maximum of 30% of this micronized polyurethane can be introduced for the production of a new windows. To identify the level of sustainability, we have the first year of the assessment, and as Leah gave in his conclusions, we perform the first year evaluation to obtain the big picture of the sustainability assessment. This big picture is based on interview and questionnaire completed by case study leaders with a person technically involved in the development of the products, with the support of sustainable experts. This matrix takes into account all the pillars of the sustainability, with environmental, social, health and safety, and economic impacts. We obtain this type of matrix where we have the identification of the main topics we have to address as function of the life cycle and of the pillar of sustainability, just an illustration. We obtain this big picture with the hotspot identification, where you have on the left the several routes, and in red the classical routes with fossil-based products. In orange you have the development routes at the beginning of the project, where a small part of biopolyurethane is reprocessed, and in green you have the routes with a closed loop where we introduce vitrimer properties. It's a link to the technical specification of the products, and we can identify the challenge, and the sustainable level. One is to have an adaptable existing currently non-recyclable materials, minimize the impact of the recycling process with minimizing energy input, solvent recovery, or some toxic issues regarding flame retardants, and allow to reform and reuse waste catalyst. At the end, we have the routes at the beginning of the project I previously presented, and we can have two types of routes of development. The first route is to change the monomer property, and it will be conducted by the LATEC in this project, to implement in the monomer this vitrimer property that allow the recycling step. And the second family of routes is the vitrimerization routes based on the use of polyurethane waste. And this family of routes is driven by CEA. And just before to give the floor to Yvonne, I just to give you some few words, what is a vitrimer and this main property and level of sustainability by using catalytic system for polyurethane material vitrimerizations. Vitrimer is based on covalent bond and on free reactive sites. By using catalyst and thermal activations, we can have bond retentions. It's on the middle of the picture, and we can obtain at the end the same covalent bond, but and at another place, at another area in the plastic. We obtain a new property of reforming, and in few words, the Vitrimer is like a reformable thermoset. And now I will let the floor to Yvonne, that she presents the life cycle developments diagram and the life cycle data collections. I will move and let the floor to Yvonne. Just a few seconds, and go back to the live storm. And Yvonne, I will try your presentations. Few seconds. You are here, and is it you one? I just check. Yeah, here. Yvonne, I think the floor is yours.
Okay, thank you very much. So thank you. Yeah, I will continue with the next steps for the case study 1, from life cycle and development diagram to the life cycle data collection. Just a short recap of what Sebastian just mentioned on the integration of JRC framework in the global approach for product development. The scheme is on the left side, and we're using the 5 different steps that are proposed in the JRC framework for safe and sustainable assessment. So what we actually do for case study 1, we have different routes that could be followed to make the end product, where we go from the life cycle stages in the columns, from the material extraction, the process construction, use and maintenance, end of life processing, end of life use, and end of life. And we have different design options, which are the rows in this picture. You have the reference route, which is the comparator route, that's the route that's normally used. And there's an initial option that can be used as an alternative. In this case, there's a difference in the end of life processing. And we can also think of alternative options, which are the rows below, where alternative approaches are followed. And that could be in different stages of the process, in the life cycle stage. That could be in the end of life processing, but that could also be with the use of different materials at the start to make it more safe and sustainable. This whole scheme of different routes and different production processes in the life cycle stages is made together with the case studies, with the consortium partners, using a virtual whiteboard. So all the routes are being identified and detailed further. And to show you a little bit on how this works, it's in the blue box on the top side. I don't know, the details are not readable, I think, but it's just to give you an idea about what process is being followed, where you identify the different materials in the blue boxes, the different processes, the use and the maintenance, and then the end of life, where the arrows indicate the process that's being followed. And we start again with the big picture of the routes, and use this to see what routes are available, what would be the possibilities, and where things could be changed. And then we further detailed this together with the case studies and to see where the changes in the route could be optimized. So specifically for case study 1, we have several different routes that could be were explored, 7 routes, 7 options for the window frame. So there were developments at the material design stage, where the formulations could be changed with bio-based PU precursors. Sebastian already mentioned this. The Vitrimer addition could be an optimization. It could also use the combination, and we could change hazardous compounds for less hazardous compounds by the removal of a halogen-free fire retardant. There are also developments at the end of life reprocessing stage. This is the catalytic system for the vitrimerization and the adaptation of this catalytic system. So that gives all these 7 different routes that could be further explored. So then to collect information on different aspects and different SSRBD criteria for this case study specifically. We had different questionnaires. There were 3 different questionnaires, or there are 3 different questionnaires. The first one is on hazard and physical chemical properties. The second one on release and exposure, and a third one on LCA, LCC. I'll just go through them briefly just to give you an idea about what kind of information we are collecting. But it's quite a lot, so I don't want you to go into full detail of this. So for the hazard, we're looking at the list of ingredients. So what kind of ingredients are being used in the different routes. And we are collecting information on the chemical identity of the compounds. We're collecting information on the polymer and monomer information. So on the there's information on the polymers, but also on the monomers, and information on the stability and the degradation of the polymers. For the EAS and NIAS, so the intended added substances and non-intended substance, non-intentionally added substances, we also collect specific information related to their chemical identity and physical chemical properties, on their stability and degradation. And we collect hazard information. There's quite a lot of hazard information here on the more general and toxicological endpoint, like labeling, whether compounds are labeled, or acute toxicity information. We collect information on specific toxicological endpoints, like the specific target organ toxicity, endocrine disruption, aquatic toxicity. We have information on the chemical hazard, so the flammability and corrosivity. And we have information on in vitro assays, if that's available or will be collected by doing assays on different in vitro endpoints. For the release and exposure, the questionnaire is based on the ECHA documentation. The numbers are listed here. It's collecting information on the material specific information. So the composition of the material, the moisture, that kind of information. As we are dealing with exposure, we need to have information on the activity related information. So how to be able to determine the exposure. And this is on the worker exposure. There's information collected, and also on the consumer exposure. And then in the end also on the environmental exposure. Then I go to LCA, LCC. This questionnaire is case study specific because these questions are different for each case study. So there's a general information. I think it's maybe a bit small to read. We have general information on the description of what the step itself. There's information on the indirect costs, so the costs that are involved in this production step. The investment costs, things like equipment, and information on other costs if that's not covered by any of the other parts. And then we have the indirect cost, the direct cost as the input, so what's being put in the product itself, so the material, consumables, packaging material, all the kind of information. And then at the end, what's also the output category, so what's the waste for different aspects, and the emissions, for example. So that was really brief, but it's just to give you an idea about the kind of information we're collecting. And just to go a little bit in more detail, I mentioned that the LCA, LCC questionnaire is specifically for each step. So that means that for every step in the process, in the life cycle stage, we have a different questionnaire. So that means that a lot of information is collected in this, for each route. So how are we collecting this data? We start with the assessment of hazard exposure, LCA, LCC, and that's according to the different JRC steps that Sebastian already mentioned. This gives us, we're doing this with different tools, and it's are the questionnaires that I just explained. And it gives results for hazard. It gives information on the data gaps in toxicity. For exposure, we can identify hotspots, and for the LCA, LCC, we have the life cycle inventory. And this leads to different actions, the different scenarios, the actions that we're using or hazard to fill in for toxicity assays, exposure assays, and modeling of impacts and costs for LCA and LCC. Which will result in, for hazard, it will result in a toxicity value. For exposure, it will result in the quantification of the release of substances, which together can be used for risk assessment. And this can be fed into the modeling of the impacts and costs and to identify hotspots. The red arrow, the red line is where we are now, filling in the questionnaires and collecting information on the different case studies and on the products in the life cycle stages. And in the end, this all will lead to the digital infrastructure where we can compare the different routes that are being explored in the case studies, and to see where the pros and the cons of each route are. So to show you a little bit of how we work in SURPASS in this case study teams, this is an example for the case study 1, but it's being applied for every case study. Every case study has a case study leader. There are leaders also for the different routes. In this case, we have for the monomer modification and the PU waste vitamerization, there are leaders. We have and then we have people involved in exposure in the orange boxes here. There's a task leader, and there are also people connected to specifically to case study 1. For hazard, we have the same task leader, and again, a person connected to case study 1. And for LCA and LCC, we also have people working closely together. So we have people working on the case study itself, but also people working really on exposure, hazard, LCA and LCC. And this is all again connected in work package 4 with the work package leader and task leaders. So this collaboration is really important to be able to work in an iterative approach and to use the information already early in the process to design the process itself and to make this really an iterative process. So what are we going to do? We have these different routes, these functional units. We have this, it's there in the Klaxoon board, all listed in the different routes. What we're going to do is to prioritize routes. Some routes may be feasible, others may not be feasible. So we have to prioritize which are the most important ones, or the ones that really would have a benefit and would still have their functionality, of course. So this would, transduce the functional unit through the flows of each step of the routes, and then complete this questionnaire for LCA, LCC, and complete this for the reference route and for the comparator route for the different case studies. And then we have an LCI for the reference route and the alternative route. And then we can also fill this questionnaire for another alternative route and have this LCI. For hazard, we also use the information from the questionnaire to collect information on the physical chemical properties and on the toxicity that could be linked together and to provide input for the case studies. The toxicity information will also be used to identify data gaps that may exist on hazard. And we'll use toxicity assays to fill these data gaps. And before that, we'll have a selection of the toxicological endpoints that would be important to assess. Ultimately, this gives hazard for the selected routes and can also be provided as input for advising the case studies. For exposure and release, we also have this questionnaire based on the different routes. We have a scenario will be selected. And that's based on how the product will be used and how the hotspots will be identified. Experimental tests will be used to conduct assays and to identify the hotspots or for the case studies. So what this ultimately would result in, we are not there yet, but this just to give you an idea about how the results would look like. For LCA, LCC, we'll get, you see it's very small on the left side. For the different routes, we can have a difference, we can compare the different routes, and based on their environmental impact, on their human health impact, on their, all different kinds of aspects of the route itself. And it's easy to compare those, and you can also compare the products in the different steps. That's here, and where this contributes most. So this again on the toxicity, in the total, and on the ecotoxicity and the global warming. For release and exposure, we can also compare the different routes. This should be seen as different routes where you can have different exposure scenarios for different compounds. So when this would be two different routes, you have an exposure of each of the compounds, and you can compare whether the exposure is different follows a different route. In this case, it's illustrated for inhalation and dermal contact. And you can see where the hotspots would be for different routes, but also specifically for different compounds. And for hazards, you can get something like an identification of the most hazardous compounds in the and what the hazard would be in total for the whole process itself, and to see whether there would be alternatives to or alternative options. And together, when we all combine this information on LCA, LCC, release, exposure, and hazard, we can identify the potential impact on the transfer to a different route for the recommendations on safe, sustainable, recyclable by design options and trade-offs. So when you would compare, in this case, the reference route with an alternative route, that would be option B. You can compare on different life cycle stages what would be the benefit and what would be the drawback. But you can also compare that based on the impact it would have on human health, environmental health, or global warming of the different routes. So as for planning, I already touched a little bit on this. We're working now on the hazard exposure LCA, LCC. We're developing the questionnaires which we did in parallel or together, and now we are working in parallel to fill in these questionnaires, and later on we will combine all this information again to make this digital infrastructure, and to be able to show the outcomes of the routes and to compare the different routes in this spider-like diagram. Just to go back and to see a little bit of what we achieved for so far. This is the scheme again, with a little bit enlarged. So for case study 1, on the technical function, we had 3 different routes that were stopped, and that's because those routes did not result in did not meet the technical specifications, so they could not be further developed. We also looked at hazard, and one of the routes was modified because there was a solvent toxicity. And for another case study, the end of life of one route was changed to move from a closed loop to an open loop to meet the technical specifications. So I would like to end with this take-home message. I think it's important in this project that we're applying a learning by doing approach. So we're working together with people of different expertises within different work packages, within different institutes, bringing all knowledge together to really take this approach in a learning by doing approach. We work case study centered, and we really need this structure to facilitate the collaborations, because that's really important to be able to learn from each other. And what I'd like to mention is that because we have so much disciplines needed to be able to achieve this, we have a new cross-disciplinary job that would be needed, would be someone who will be able to oversee everything and to be like the SSRBD case study manager. So with that, I'd like to end the presentation and thank all the people involved in SURPASS and in this work. And I'd like to thank you.
Thank you, Yvonne, and thank you, Sebastian, for giving this nice overview and the detailed overview of the SSRBD approach implemented in SURPASS. So now we have time for a couple of questions. We have already one question from Elena Montero, which has received also 3 votes. So I will read now this one, and in the meantime, if you have other questions, just type it in the question button on the bottom right. So Elena is asking, have you already thought about how good is good enough to stop the development stage? And this regarding the different SSBD criteria, LCA, LCC, social.
I can start, and even if you would like to complete, do not hesitate. I think it's a very good, important question. It's related to the scoring system and establishment of the scoring system and to balance between the several pillars. They have some proposition in the reports for case study from the GRC, but they said it's in discussion. And I think we will have to work on it SURPASS project during the step of integrations, and to decide this level, and it will be related, and our starting point, I think it will be the KPI and targets fixed in the proposal as the sustainable solutions, and we will see where we are at the end of the project compared to these target and KPI we fixed at the beginning. But I think it's a part of discussions and of test the framework that Leah presented at the end with the arrow and the agenda of these presentations. These parts have to be tested in several projects to try to have this scoring system. And this scoring system will be changed, I think, as function of the sector of the products you are developing. Even if you add some elements.
Yeah, I think it's really like what you said. It's really the learning by doing approach. It's the question. It's a really good question, but I think it's one that we can't answer yet. And when you would say good enough, if you only have benefits, then it would be better, of course. But I think we also have can have cases where you have a benefit on one side and a drawback on the other side. So we have to see what would be good enough in that sense. So yeah.
Okay. Thank you very much.
Hi, Andrea. So if I will be the first speaker, I guess, then we will exchange. I mean, Diogo, it will also speak in the middle of the presentation, and then we'll come back to me, and then finishing by him. And then, so I will start sharing the presentation. Let's see if I can do share Google. Okay, share screen. I'm not sure. Well, a little bit confused with this. Okay, I'm trying to share the screen. Please let me know because it's going very slow.
Now we see your full screen, but it's empty.
Okay.
Now we see your presentation.
Okay. So, well, first, let's say good morning, everyone. So, as you introduced me, but I will do it again. So, I'm Elena Barbero. I'm working at Aitene. And in this presentation, I'm together with my colleague Diogo Teixeira from ISQ, we will give an overview on the safe and sustainability approach that we are aiming to implement in the Redondo project. Also, first, I would like to thank Sia and especially you, Andrea, for the organization of this workshop and the support during the preparation, and also for giving us this opportunity. So, well, as I said, that my colleague Diego and me will be both present the Redondo project, but will be more focused in safety and safe by design aspects, whereas Diego will be more focused in the sustainability aspects. So it's because of that we will be contributing both in the presentation. Okay, so in the following slide, yes, I have presented here the outline of the presentation. We did our best to adapt the content to the agenda. We also would like to give an overview of Redondo project at the beginning in general terms. And then we will explain the operational approach in terms of how we are going to organize the work. On the last part of the presentation, we will focus on how we approach the SSPD strategies from a case study perspective, and we will include the description of the assessment that we are expecting to conduct. Okay, let's start with an overview. Yes, in this slide, I have collected a general information about the project. You see here some numbers. So just to remark that Redondo is coordinated by the Aristotle University of Thessaloniki in Greece. The consortium is composed of 11 partners. I will give more information about the partner in the following slide. And just to finalize with this slide and remark that the project started in September of 2022. So we can just say that we are at the beginning of the project, 1 year, more than 1 year. About the consortium, and as I said, we have 11 partners from 6 different continents. These are Greece, France, Spain, Czech Republic, and Germany, and Portugal. Among the consortium, we also have involved partners from the academic, also research institution, but also SMEs, as well as one large enterprise. So here is the list of the participants. You can see the country and the type of institution. More just into the project. Well, first starting for the project motivation, and the Redondo project has been motivated by different facts. Among other, the need to provide strategies for recycling plastic products in a safe and sustainable way. You probably know many of the polymers widely used in the plastic industry cause a negative impact, both on the environment and human health. So it's also new that this polymer release dangerous substances during the whole life cycle from the production processes until the disposal or recycling stages. So attention must be paid to the recycling stages and also focusing on recyclability and safety of this polymer from the design stage. And in particular, we should focus our attention on this kind of polymers that are widely used in the plastic industry. So these polymers are often challenging to recycle. They have a high impact on the environment and human health. Yes? Can you hear me well? Sorry. Can you hear me? This is...
Hi. I will ask other speakers to please close your microphone because we can hear not simply Elena, but also someone else.
Okay, thanks. So I was just saying that these polymers are really difficult to recycle in many of the cases, causing a high impact on the environment and on human health. This is a specific case of the cross-linked polyethylene. From this, I think that Redondo is a project that is dealing with the cross-linked polyethylene and the strategies to introduce recyclability in cross-linked polyethylene products to improve their environmental footprint. So what happened is the cross-linking is used to change the nature of the polyethylene from thermoplastic to the thermoset. And this is, from the point of view of functionality, it is really highly desirable because thermoset plastic exhibits improved thermal stability, chemical resistance, and structural integrity. However, the cross-linked polyethylene is being thermoset material is not easy to be recycled. This is because Redondo aims to achieve a fully reversibly cross-linked process that will be to enable the synthesis on reversibly cross-linked polyethylene. This is basically the aim of, the general aim of these projects. Also, I would like to go deeper into objectives that are specific from the point of view of safe and sustainability by design. So one of the specific objectives of Redondo in this term is to ensuring the safety of the human health from the early stage of the development, as well as selecting the safe by design criteria for recyclable cross-linked polyethylene. This objective will be achieved by development different strategies and risk mitigation strategies in order to reduce toxicity of the material while preserving while keeping their functionality, which is really important, as I mentioned before in the first talk. In particular, the specific strategies will be developed for RPEX and its additives, and also for the derivative formulation and products. We will be focusing mainly into approaches that is safe by material and safe by process design. This is related with the safety approach. And while the first one is focusing in the inherent properties of the materials, the second one is focusing in the avoidance, the release of the exposure to hazard substances during the production process. The other objective, a specific objective in Redondo related more with the sustainability terms, is to ensure the sustainability of the process and the product itself. So we are going to address these objectives by assessing the environmental and socioeconomic impact of the developed products and processes, following different methodologies like life cycle assessment and life cycle cost. In addition to this, the recyclability of the materials will be evaluated. Other factors contributing to the sustainability dimension will be also evaluated. At the end, what we are aiming is providing a strategic roadmap for the promotion of a circular economy. Yes, this is basically what I was trying to say with the overview of the project. In this this part of the presentation, I think I just need the contribution from my colleague Diego. So, Diego, please, the screen is yours, and please let me know whenever you need. I go forward with the slides.
Thank you, Elena. So now looking at the practical approach, implementing the safe and sustainable framework for the project, we can go to exactly the project at a glance. We have 5 steps that we need to implement during this project. First is the design and the synthetic path that will focus mainly on the chemistry and the reversibility of the polymer. Then we're going to look at the novel bio-based and green additives formulation, for example, nanolinin and nanocellulose integration. This will help the properties of the materials. After that, we're going to focus on the production and then compounding of the materials. Here is where we're going to focus also in the safe and sustainable by design aspects and the placement tool for circularity. After implementing this production compounding, we'll look at the demonstrators because the final product are either pipes or cables made from the reversible cross-linked polyethylene. And the final step is recyclability, which is what the reversible part stands for in the reversible cross-linked polyethylene, is to obtain a reversible and recyclable polymer to produce both the piping and the cables. Next slide. So the main problems and solutions that were found in the project. The problems are the release of potential harmful substances from the cross-linked polyethylene. They usually come from the volatile components and on the plastic pipings production and the additives used in the manufacturing of said pipings. The solution is then to first focus on the recyclability, making it a more safe and environmental friendly in the design stage, and this is where the safe and sustainable by design approach begins in the project, where we include the studies and determination of specifications and requirements associated with the development of these RPEX and its additives with the selected end-use applications, as well as with the recyclability by design trait. The organization of the workflow mainly focuses in 3 work packages, but the safe and sustainable by design approach will cover a little bit more, and we'll use some outputs from other work packages, but mainly focuses in work package 2, 6, and 7. The work package 2 focusing the specifications and requirements of this material, while the work package 6 and 7 will focus the health and health risk and environmental assessments. And in this, for the consideration and integration of the safe and sustainable by design dimension, the Redondo will follow a criteria system approach. So it will identify based on the assessments which are the most reliable criteria that we'll need to implement and make an SSBD assessment. So next slide. Here we're going to show exactly the organization of the other work packages. As mentioned before, work package 2 is the specification and requirements of the material that will provide some information on both work package 3 and 4, with the work package 3 being the synthesis of the polymer, while the work package 4 is the production of the additives and the formulation of said additives. All of these 3 work packages will provide also information to work package 5 that is focused on the compounding and validation of the end applications, so the pipings and the cables of our packs. And after being produced, we have work package 6 and 7 working in collaboration with all these previous work packages, making the assessment for the safety by design aspect in work package 6, providing some criteria definition in hazard assessment and exposure assessment, and have work package 7 working in the sustainability assessment, also establishing said criteria, but focused on life cycle sustainability assessment and recyclability assessment. So next slide. Here, looking more for the side of the SSBD framework, we're going to also look into the raw materials, not only for the choice of the reactants, but understand what are the emissions that are going to, and the exposure levels. Then looking at the functionalization, the functionality of the process, the reprocessing of the polyethylene, the cross-linked polyethylene, and said characteristics. This part of the functionalization will come from work package 2, as well as the conditions of use, the specifications as mentioned before. Then after that, we're going to also focus in the end of life and the recycling, the recyclability, which is one of the main goals of this project. And all of this will compile in the safe and sustainable by design approach on this project. So next slide. So in conclusion, for the project, the work plan focuses in these 4 main stages, which are the reversibility of the cross-linked polyethylene, the sustainable and green bio-based additives, also then the safe and sustainable by design, and finally a validation of the demonstration activities. In terms of safe and sustainable by design, in the next slide, please. This approach will be based in the 4 main pillars. So the recyclability, which we already mentioned is extremely important in this project, the recyclability, the life cycle sustainability assessment, the safe and sustainable by design framework, and the placement tool for circularity. In terms of recyclability, on the next slide, the main objective of the recyclability assessment is to highlight the recyclability of the new materials with the quality of being used, being reprocessed. We're going to test it in different scenarios that will be presented depending on the quality of the material to be reprocessed. Once the processability of the demonstrators, the recyclability of the materials will be also validated based on reprocessing of the pipes and cables. And finally, there's also going to be a MFA, a material flow analysis for the additives. So we're going to analyze the value chain of these additives, and this MFA will also feed the placement tool for the circularity. Sorry. So yeah, this MFA we're going to look at the material flow analysis, and it will be one of the major key informations for the placement tool. So now in the life cycle sustainability assessment, we're going to look at the 3 pillars of the sustainability. So we're talking about environmental, social, and economic aspects of sustainability. In terms of SSBD framework, these last two, the socioeconomic, are a little bit under development, but we're also going to try and understand what will be the best approach in this project. But the main focus of this life cycle sustainability assessment is to understand which are the hotspots for the process and the use phase and the end of life, and talk to partners to see and where are the best improvement aspects and where can these RPECs be improved in terms of sustainability. So all these results of this sustainability assessment will feed the SSPD with the criteria definition. So next in the SSPD framework, next slide. Exactly. This concept, as mentioned before by other colleagues, the concept aims to prevent adverse effects on both human health and environmental impacts, and focuses on also addressing the toxicological effects and potential exposures during all its life cycle. So as mentioned before, the socioeconomic aspect, although it needs to be developed, we're also going to use this last step, the step 5 from the framework, in our assessment and our final results for the criteria. So the Place Me tool, on the next slide. So the Place Me tool integrates the reversibility, cross-link polymers, and the recycling technology, taking into consideration simultaneously all the available finite uses by using optimization models to solve and predict optimal solutions. The assessment will recommend an optimal network connection based on multi-objective optimization, and a step further is to align this tool with a Redondo digital tool environment that will be used by the end users to engage themselves in navigating through the value chain with a holistic monitoring, produce, enforcing safety and sustainable from the very early stage. So it's a tool that will help others after the project to implement also this type of framework. Okay, so next slide, please.
Okay, I'm trying to go for the next, but I don't know what I did. So I don't know. I cannot move. Maybe just starting again to share.
Well, I can try to share it as well.
No, I can't because I think. Okay. Well, sorry for this inconvenience.
No problem.
No, because well, I have controlling very well, and now I don't know what I did. Okay, I will start sharing. Sorry for that. Now I cannot find the. Okay. Well, sorry.
So Elena, if you want, I can remove your screen share, and so that either you or Diogo can.
Okay, I will. Okay, let's try again. I think
maybe. Oh,
it is visible now.
It's loading. Yes,
Okay, but the thing is that I cannot control it now. I don't know why. So because yeah, it is moving right now. Yes, sorry for that. Sorry.
No problem. So moving forward, the task distribution for work package 6 and 7. In work package 6, we'll provide experimental results related to the human hazard and potential of materials in each case study. These results will in turn help the criteria definition. Then we will be combining the results from also work package 7 that has the sustainability assessment, environmental, social, and lifecycle costing assessment, also the recyclability. We're going to combine these aspects with the functionality and the cost criteria from the safe and sustainable framework. Finally, the integration of these criteria will result in a human and environmental risk assessment score obtained from each case study, which is the final result that this framework wants to develop. Okay.
Now I think it's my turn again. So, well, yes, it's in this part of the presentation. what I'm going to do is just give more an overview of the first starting with a general perspective of Redondo. So the partners that will be synthesize the RPEX will be close collaborating with Xylem, which is the partners with this, the master batch formulation, and also the end users, to determine the requirements in terms of throughput and reaction conditions, chemical additives, temperature, and so on. And also the synthesis requirements are based on the fundamental understanding developed previously by all partners. So the by design principle for the material selection as well as other production processes will be aligned for sure with the European framework. So for that, we will consider principle basis on green and sustainable chemistry, and as well as circularity by design. So the results of this work will help us to set up the material specification in terms of process validation requirements, and this will be useful for the final assessment. Then for next, I will also focus on here that we are not only going to focus on the material, which is the main material, which is the RPEX. Also, we are going to apply our approach to the additives that we are going to add to this polymer. So in the Redondo project, we are going to develop different types of additives. Among other additives, we will produce lignin and cellulose-based additives, which are considered like green additives. This specifically will be developed by partners from Creative Nano and also by ITENE, our colleagues from ITENE. The purpose of these additives is to improve the mechanical and thermal properties of the RPEX. Since these additives are nanomaterials, it is really important to investigate the safety requirement for this. We will then apply or implement the appropriate processes to ensure the safety of all the production chains in the final products. So the requirement of these novel nano additives in terms of properties and processes will be defined a priori, as explained before also my colleague in Work Packet 2. So all the specification we will determine through the close collaboration from the nano additive producer, that is the Work Packet 4, with formulator and user, which are also in Work Packet 5. Yes, in the case of the case study perspective, yes, I will just give an overview of the case study we are going to have in this project. So we will have two. One of them is the pipes. So we will study to develop the pipes from tubing and from plumbing and hydronic systems. As you know, the pipes are mostly composed by cross-linked polyethylene. It's about 60% of the material. So the aims of Redondo is to provide to the end users an alternative and recyclable material. And of course, we will need to provide a free of toxic substance material. During Redondo, we will develop 3 different types of pipes, so with different diameters, that will be all developed using recyclable cross-linked polyethylene. So we will start with a preliminary RPEX formulation, then it will be gradually optimized, taking into account the consideration and recommendation from the SSBD assessment, and also according to the result of the functional testing. Okay. In the other case study that we have in the project, which is in the formulation of photovoltaic cables, well, these cables are used to connect the solar panels and other components in the photovoltaic system. And as you see here, this is a real images of this kind of cable. It is double insulated. So what is important to mention here is that these cables must resist the adverse condition. So they have to have, well, the functionality is really specific because they have to be exposed to moisture and high temperatures, also to UV radiation. But also it must be safe. For example, it must be resist to flame propagation. They will be developed following the corresponding normative to ensure the technical properties, but also ensure the safety and durability of these products. So safety and sustainability aspects will be considered also for the evaluation when in the validation stage. And now, I think if what I'm going just to explain is well, it's a little bit. I would like to introduce case study, but now I introduce the case study. I would like to talk about how we are going to approach the SSVD assessment following the well-known step of the GRC framework. As I commented at the beginning of the presentation, we'll be focused here in safety aspects. So it's because of that I will just comment first in the three first steps. Also, I will explain the assessment conducted during the steps. And then my colleague Diogo will come again and talk about the details of the sustainability and social assessment that is conducted in the 4 and 5 steps. So in the first steps, we are going to do is look at the chemical properties of the substances. So for that purpose, also we will deliver specific questionnaires. And in the case of the previous talk, we will have also a general questionnaire for deliver to the partners and collect the information regarding the substances that are using and all the specific physical chemical properties of material. So what we are doing then is to establish a criterion according to the intrinsic properties. We will be able to classify these substances according to the different hazard categories. And then we come to make some recommendation in the substitution of that one that doesn't meet the safety criteria. For the second step, what we do is like, okay, so we are going to assess the human health and safety aspect during the production process. On one hand, we are going to experimentally evaluate the hazard of the chemicals by conducting in vitro tests. Also, we are going to analyze the potential emission and exposure of the substance at the workplace. So for conducting this assessment, we will need a coordination, really good coordination with the partners in charge of the material development. So this is the work package 3 and 4 partners, basically. Since they will need to send samples for their analysis, and also because we will conduct exposure campaigns in their facilities to characterize the exposure. So in this stage also we have some questionnaires that will be delivered and prior the campaigns. So in this way we can understand very well the process that they are they produce in the production process and select the proper instrumentation and equipment for the measurement. And depending on the result of this assessment, we can also recommend the implementation of safe and material strategies. It will include, for example, the modification of the redesign of the material by applying surface chemistry. Also, we can recommend some safe by process strategies that can be like implementation of modifying some aspect of the production processes. The following slide, yes, is the third step, and this take care of the human health and the environmental aspect in the final application phase. So the goal is basically that, and we are just aiming to determine if any of the chemicals or material used in Redondo and in Redondo final products will cause any risk to human health of the environment. So for this purpose, we will test the final product during laboratory experimental tests, aimed at the simulation of the real condition of the usage. In this manner, we could assess their safety, but also their functionality with a specific test for that. At the end, we will all these results. What we are going to do is develop environmental and healthy safety roadmap to provide and help the stakeholders on the design of Redondo materials and final products. Now, what I'm going to just explain is a little bit more of the detail of the assessment that we are conducting during these three steps. So I will start with just remembering the objectives of this assessment. So one of the objectives is to consider safety of the reversibly cross-linked polyethylene. from the early stage of the development and to identify the critical parameters that could affect the safety of the risk. So also we are aiming at the generation of the experimental information of the toxicological profile of the chemicals and material used during the whole life cycle. And last, another objective will be to define a criteria regarding the safety of the RPX products and the additives. So for the safety assessment, we will define these safety criteria from the early stage, as I mentioned before. The safe by design strategy will be aimed at minimizing risk and consideration the properties of the material itself. I think this is a little repetition of what I have presented before, but okay, coming to the particular case of Redondo project, we will generate the toxicological information as well as exposure information in work package 6, but we will need the information coming from other work packages, and especially from work package 3 and 4, which are in charge of the material development. This slide is just more focused on what we are going to do in terms of the assessment. So you can see more details, specific assessment, and conducted under task 6.3. This is for the toxicological assessment. We will perform this test, which are based on OECD protocols, using human cells that simulates the main entry routes in the human body. So in the case of the inhalation route, we will test the materials in alveolar cells. In the case of dermal routes, we will use an epidermal. Okay, I think you are not. Okay, this is the animation that I want to show. So in the case of the epidermis cell, the line, also we have the ingestion route with the Caco cell line. They are representative for the colorectal epithelium. So the potential effect that we are going to study will be the cytotoxicity of the materials, but also with cytotoxicity is the effect on the cell function. And the genotoxicity will give us the information about the damage in the DNA. And also, we are aiming to study the inflammation response of to the materials. The other slide that I want to show you, and I think this is the last one, is related to the safety, but in terms of safe by process design. So the assessment related to the occupational exposure will be included 3 main stages. In the first one, we will analyze the process, and it is because we are sending this questionnaire with questions related with the workplace, like the dimensions, the operations, the workers that are working, and the chiefs. So we will include a detailed analysis of the foreseen exposure scenarios and the type of nanomaterials and nanoproducts involved. And the second stage, we will do a pre-analysis of the potential risks and exposure stages during the life cycle following the exposure models. It will include qualitative analysis, and also in the third steps, what we are doing just is the experimental measurement. It is basically exposure monitoring campaigns and characterization of the emissions in terms of particle size distribution, mass concentration, and number of concentration. Then, according to these results, we will define the proper risk management measures when they are needed. And I think this is all from my part. Then the next slide, yes, is for the step 4. So is Diego, who will be in charge of this. So
thank you, Elena. Now going for the step 4, the environmental sustainability assessment. Well, the goal here is to assess the life cycle of the product and assess its performance in various impact categories. So the work comprises of the data collection from the pilot processes, then applying the ISO 14040 and 14044, which embodies the framework of the life cycle assessment, and have a first analysis of the environmental hotspots and recommendations to lower the impacts with the other work packages. So the formulation, the additives formulation, the polymer formulation, and the construction of the final product will have a close collaboration with this step as well to see some improvements on the impacts. So in step 5, we'll look then to the next slide, sorry. Yeah, exactly. So in the step 5, we look into the socioeconomic aspect in the sustainability assessment. We're going to introduce both the life cycle costing analysis and social life cycle assessment. In the life cycle costing, we also estimate the cost of the different demonstrators, the cables and the pipings, and support the upscaling of the processes, and provide also some recommendations for the most economically viable pathway. In the social life cycle assessment, we're going to make use of generic and site-specific data to complete both the environmental and the life cycle costing assessment, and have a holistic sustainability assessment. And this assessment focuses on the potential social life cycle impacts and hotspots on stakeholders throughout the life cycle of the process. So from the cradle to grave system boundary. So in the next step, the next slide, sorry, Elena. Exactly. So we're going to talk a little bit more, exactly, about the framework of the life cycle sustainability assessment. The goal scope is the first step, which has the product selection and system boundaries, as mentioned before. In the safe and sustainable by design framework, the most preferable system boundary is the cradle to grave. So we can tackle also the end of life and the use phase. We establish a functional unit and a flow chart of the process in all process stages, and have a methodology definition that embodies the allocation and some cutoff criteria that must be applied for the specific product. After that, we have the life cycle inventory, which where we look at the process and the product being modeled and have a full and holistic data collection for the inputs and outputs, with whether are there materials or energies, or for example, social impacts. So we look at all the inventory possible for our analysis, from the environmental to the economic to the social. These questionnaires will be sent to partners and all relevant stakeholders. And the data that we'll receive is in those questionnaires is a primary source. But we'll, in some cases, also need to have secondary data from literature to fill some gaps and some data that is missing or that cannot be measured by our partners. So after having all this inventory compiled, we go for the life cycle impact assessment, where we select also the environmental impact categories and the methods. And by a multi-criteria comprehensive LCA, we cover all relevant, not only environmental, but also costs and social issues related to the product supply chain. After that, and final, after we obtain the results, we have the set interpretation, where we look to the hotspots. We try to make some sensitivity analysis to see which steps change the results of the assessment, and try to have some meetings with the partners and discuss where are the improvement options. On the next slide, we'll look at the environmental data. Exactly. Okay. So this is the type of data that we collect and the final result. So we look at all the steps, either from the product formulation. Here we see, as we have the final product as the end of our boundary, we see a cradle to gate approach. But as mentioned before, we'll try to make a cradle to grave to embody also the end of life. So we look at all the steps. We see which are the materials, which are the emissions, which are the consumables and wastes produced in each step. We make the assessment and then have the result based on said assessment. We'll try to have some feedback with the partners and see which are the stages that we can improve. These assessment will help basing the criteria definition for the task 7, for the work package 7, and in terms of sustainability. So in the next slide for the LCC and social LCA. Okay, in the economic parameters, we try to compile the total cost of the materials, equipment, the labor and the waste produced and the waste treatment, and also divide it by steps. to have the similar approach to the environmental assessment. And in terms of social indicators, in our social LCA, we'll try to have an approach based on the UNEP guidelines that suggests a reference scale approach where we compare a baseline and the compliance level for all the social impacts and make the assessment of the the stages that we are looking for the RPEX and compare them and have a social indicator result. Finally, in the next slide, the KPI performance that we're looking for in the safe and sustainable by design criteria, the framework, are some in human hazard as the no observed adverse effect level, the low observed adverse effect level, some exposure levels as released from matrix, some material costs in the cost analysis, in the environmental on step 3, the ecotoxicity, in the last steps, the step 4, the life cycle assessment, step 4 and step 5 of the framework, and some functionality of the specific KPIs for each case study and each demonstrator. Now, yes, the final slide. So next one, exactly. These are the results that we will work towards. These are the tables that the framework, this SSBD framework, tries to implement in the projects. So this is the results that we started looking and started having an idea to what are the type of data that we're going to collect to have this final assessments. This is the work that we're going to work towards to feed the rest of the work packages and to understand and have some feedback to which indeed is the best approach for the RPEX. So yeah, in the left part, we have the framework based on the results and the tables based on the framework that we discussed the dimensions, the aspects, and each score of the aspects and the compliance level or not. And finally, have a table with the case studies and all the possible approaches and have them compared all in the same categories to see which is indeed the best approach.
Thanks a lot, Andrea. It will be me who is starting. And hope you can see the screen and the presentation.
Yes, we can see it.
Okay, perfect. Thanks a lot. So first of all, thanks a lot for organizing this event. And we are very happy to be here and hear more about the sister project's approach about the safe and sustainable by design. And as you mentioned, it will be together with Berlin from AIM Plus that we will represent the Repurpose project. So just to start with, I would like to introduce you the project really shortly, just to put in the whole topic into the concept or what we are doing in Repurpose. So as Redondo project earlier, we also started at the same time, so the 1st of September last year. So we exactly 1 year running now into this project. We are altogether 12 partners nicely distributed in Europe, as you can see it on the map. And from these 12 partners, 2 are associated partners to the consortium. And the whole project is coordinated by Biobase Europe pilot plant. So what we are doing in this project, for some reason, the slide is not coming through. Where I have an animation. Yeah, sorry. Then I will need to go through this slide. For some reason, I do not know why is it not working. So this figure is representing the concept of the project, what we are doing here. And you can also see on this concept figure that actually I just wanted to show it after going through step by step on the concept, where the different partners are contributing and actively participating in the different tasks. So since I cannot do the animation, I will try to guide you through this figure. So if you look at the left side of the figure, you can see that actually we are starting our value chain from locally produced post-consumer waste.
It's two different wastes that we are considering. On the top, you can see that it's plastic waste and it's also paper and cardboard. These are the two wastes that we are considering in this project. Both of the waste are actually treated. So the plastic waste is depolymerized by enzymes, and we have partners who are developing the enzyme within the project. And the paper and the cardboard, it's also degraded by enzyme, but it's also the produced carbohydrate or the sugars afterwards used to fermentation to produce the building blocks. So this is how we call the REP building blocks are actually originating from these two post-consumer waste. Then there is this building block production is actually upscaled by us. So this is where we can demonstrate these processes in higher TRL level. And when the process is upscaled, then we are able to deliver these building blocks to our partners who will actually develop the polymer, the polymerization. They are able to process it. And as you can see on the right hand of the slide, we are targeting three different applications at the end of the project. It's consumer good, it's automotive, and it's building industry. So these are the three sectors that we are targeting in the project. But of course, since we talk about recyclability, we are also checking that how these materials, after they have been used, can be collected, how they can be sorted, if it's requirement some kind of new sorting method to be developed, or how it can be repaired as well. But we are also looking into how it can be recycled in an enzymatic way. So our partners are also looking into developing enzymes that are specifically targeting this polymer that we are developing in the project. This polymer, we call it a REP polymer, and this is actually the name of the abbreviation of the project Repurpose is coming from. And this is a thermoplastic elastomeric material that we are targeting for these three different applications, as I mentioned before. So just to summarize, the project scope is to develop a safe and sustainable by design thermoplastic elastomeric prototype from post-consumer waste that it's also insists biodegradability and the recyclability properties. So to ensure that we are fulfilling all the requirements, there are four pillars that we are considering during the projects. The first one is to ensure the safety and recyclability of the plastic that we are developing, enhance the safe and sustainable by design process in the plastic sector. Also, we want to make sure that we can demonstrate sustainable conversion of the elastomeric plastics, and we also want to strengthen public awareness and support for sustainable plastics and standards. Our activities are divided into different work packages, and I would like just to show you that how we divide it. So in the middle of this dotted square, you can see actually all the technical work packages that are targeting the technical research work, for example, the enzyme development, the production of the different lignin blocks, the polymer development, and also to test the recyclability, to test the different application possibilities. And as you can see, we have a dedicated work package to safety and sustainability by design that it also contains LCA analysis, of course. And Pauline is the one who is leading the work package too, and therefore she will take over the presentation from me in a second. So just to show you that our team actually had a meeting last week in Vienna after 1 year running into the project. So we have a very recent up-to-date in the project. And of course, if you are interested to follow the developments, we would like to invite you to follow our social media. And with that, I will stop sharing and I give the opportunity to Belén to share the screen and take over the presentation from me.
Thank you very much, Sophie. Thank you very much, all of you, for joining, and for sure, Andrea, to me know your team. I'm going to try. Can you see the presentation?
Yes.
Yeah. Okay. Thank you. Okay. As Sophie has explained, I'm the WordPass leader of this one focus on safety and sustainable by design, WordPass 2 in our case, and these are the main objectives to be achieved in it. The first one, of course, it will be to analyze and align the framework conditions related to the development of these new REP polymers through this safety and sustainable by design approach, but also considering at the same time the just transition mechanism through a responsible research and innovation concept. We will go into more detail later. One of our main targets also is to produce an inventory of additives, quite general for the plastic industry, but for sure more focused in our applications and in the polymers related to our raw materials that we are using as feedstock from the waste, and with the families of polymers that we are going to develop within this name of REP polymers. So in this sense, this inventory of additives, their main aim is to have as much information as possible, because it's true that in the inventory developed by ECA and other related organizations and in different regulations, etc. It contains a lot of information, but sometimes there are some gaps. Although there are a lot of information, it has been seen that gaps are, of course, in every list, because if not, it will be a very, very, very long information that could not be said in this type of documentation. So our aim is to go into detail in the additives information related to toxicity and functionality with this concepts that we have considered. The main sectors of applications in our case, that are the ones that Sophie has explained: the building, the consumer goods, and the automotive, and to select which ones should be more relevant to be replaced. Although the ECA and other regulations as REACH have been in-depth studied this type of substance of concern, it's true that we are going to try to gather as much information as possible. The three pillars of sustainability, of course, it will be assess, the ones that have been described in all the previous talks: social, environmental, economic, and as in the rest of projects that you have mentioned, that you have described very well, of course, all the regulatory aspects and the required standards will be fulfilled. We are going also to prepare some guidelines, collecting the best practice learned from all the processes involved in the project, and these best practices, the aim is to be safe, to be open accessible, but will be safe in this type of workshops and related events with the co-sister projects, of course, leaving away the parts that will be confidential. But the aim is that at the end of the project, we will develop an open science document to be shared among the plastic industry and community in general. The main concepts related to the methodology are focused on these four pillars. The safe by design, in which one of our main challenges is to produce plastics free of additives, of course, the ones that represent any kind of hazardous properties, but not also the polymers, as has been mentioned also in other speaks, but also related to the monomers that are used to develop the polymers, but also the additives. We are going to ensure also that microplastics are not developed. At the end of the process is mainly we are going to study this in the biodegradation step. We are going to tune the polymer structure to tune also the biodegradation, although the main aim in this project is to produce recyclable materials. The biodegradation, it will be also evaluated. It will be, we can say, the last option of end of life in this type of materials that we are going to develop. And of course, has to be fulfill all the regulations related to the safety concepts, but also with the applications, with the technical requirements and the sectors of applications of each one of the products that we are going to develop. In other block, we can talk about the functionality and the process design. As we have mentioned, thermoplastic elastomers are the polymers that we are going to develop for different value, high value applications and sectors. The aim is to use local resources, and these sustainable building blocks that we are going to be produced should be obtained considering these local resources, these plastic waste resources in our case. The biotechnology, it will be the main route to be developed, and the polymerization will make use of existing and conventional equipment, but taking into consideration for sure that we could include some advantages, some tools to make more sustainable the processes, like the monitorization, etc. The upscaling, it will be addressed to reach this TRL 5Cs at the end of the project, with these scaling processes in the case of the building blocks, but also in the case of the polymer production. In the part of the circular and resource efficiency, we focus our attention in the durability and the reusability of the repolymers as first stage, because, for example, in construction or automotive, you know that this is a requirement. We focus also our attention in the design of the constructive solutions to make easier the dismantling and even the reparation or maintenance tasks for these materials. We are going to evaluate also the enzymatic recyclability by developing structures, chemical backbones that could be easily break through the effect of enzymes at the end of their life, of course. And we are going to use commodity plastic waste, paper and cardboard waste, and also lignin from biomass as feedstock. Related with the last one, our conditions consider, as I have mentioned previously, the responsible research and innovation concept. Our aim is to involve as much stakeholders as possible and achieve an effective engagement of them. For this reason, all the organization of events, workshops, and in general, our aim is to try to reach as much public in general, even to reach students. This is something that we don't have to forget, and although the industry and the academia are the first ones or the first objectives, all these type of publics it will be considered in this project. We will cover all the parts of the sustainability dimension, the circular value chains that we are building is foreseen that the business models that we are going to develop can reach the production of startups and the exploitation. It will be one of the focus, and we will foster the symbiosis, of course, with other co-sister projects like these ones or other projects related to these concepts of safety and sustainable by design. If needed, we will prepare also fast standards that will be presented in standardization committees, because some of the partners involved in this consortium belongs to this type of organizations, committees. Our approach is multidisciplinary, as you can see here. So we cover all these type of backgrounds, expertise, starting from, for example, from the waste management and valorization with RENASI, protein engineering, by epoch, metabolic engineering, also with the University of Saarland, the industrial biotechnology and upscaling with bio-based Europe pilot plan, communication and dissemination, as well as sustainability assessment, innovation management, and social science RRI stakeholder engagement by ITB. The part of the toxicology with experts in toxicology and ecotoxicology by MATEM, polymer manufacturing, processing and recycling by before plastic and M+, the detection and spectral analysis by photoemission, the production, design, fabrication and disassembly by the University of Aalborg, and the policy, the standardization and regulation by M+ and NABEP. So the methodology in which we are basing our safety and sustainable by design approach could be drawn with these different steps. The design and the scaling up of the best balance between functionality and, of course, the evaluation of the cost and the environmental impacts. Our aim is to steer the polymer properties. We develop chemical structures to reach the different requirements that will be needed to be used in the different sectors that we have mentioned. We start the work, or we can say that we have started the work, because this is something that it has been the first stage of the project and has already been accomplished with the development of a first rep polymers that could be switched in functionality and properties with some modifications in their structure. So with this starting point, we are in fact developing a platform of rep polymers by combinations of different ratios of bio and waste derived building blocks that have been developed from this waste that we have mentioned, the plastic board, cardboard, the plastic mixtures of coming from local and common waste management sources. We can continue with the development of these building blocks and the evaluation of the process conditions, the rep polymers properties, their processability, and their potential to be applied in the different sectors of applications and products that we have defined. Here you can see some examples of them for these three sectors. We also focus our methodology, safety and sustainable by design approach in the production of different semi-finished prototypes, semi-finished materials by conventional technologies like extrusion, foaming, injection molding, 3D printing, that will be post-processed and will be it will be subjected to some physical forming to develop the final products. So we will tailor-make the properties by configuring these chemical structures and by modification of the polymers and the processes related to their production. So all the materials that we are going to develop, it will be compared to conventional plastics as benchmarks to be sure that the developments that we are producing are safer and more sustainable than the ones that our aim is to be replaced. We are going also to test for specific applications these materials that we are developing with an end user group that we have configured in the project. And it's important to highlight that the main aim is to reuse or to give long duration to the products that we are going to develop, to demonstrate that bio-based materials could also be switchable to be used for this type of applications. In this sense, we are including a part of recycling by applying design for the construction model based on computational algorithm designs. So taking this into consideration that our first aim is the reusability or the long durability of the materials, and when these materials will not be effective, we will reach at the end their life, because it will not be possible to reach a higher number of cycles of reuse or repairing, etc. Then they will be recycled. It will be recycled by mechanical recycling first, as a preferable end of life, and chemical recycling in other cases. Finally, the biodegradation, it will be also evaluated, as I have mentioned. But it will be the last end of life as preference in our case. To make easier this recyclability in the sense of enzymatic recycling, the chemical structures of the polymers that we are developing are based on a concept in which the skeleton could be break, so we can trigger this enzymatic recycling effectiveness. We are going also to implement spectral and visual techniques to be used in conventional waste sorting lines to demonstrate that our polymers, our rep polymers, could be easily identified and separate from other type of polymers in this type of lines. And as I have mentioned at the beginning, the microplastic and nanoplastic evaluations, it will be considered also, mainly when biodegradation is the end of life. As you can see here in this slide, different biodegradations assessment, it will be done by measuring industrial composting, anaerobic, marine, and soil conditions. Of course, marine is not, the aim is not that this will be the end of life of any material that we are going to develop. Marine biodegradation, it will be evaluated just to confirm that in case of some accidental littering, this result could not affect and if we achieve a complete biodegradation in this media, it will be great. So we are going to develop all these processes and the materials by considering an iterative work. So as soon as we are receiving information, but not just from this test that we are considering now, but also from the LCA, LCC, social LCA, and a redesign of the developments, it will be considered in working in this iterative way. Related to safety and toxicity, for sure, REACH and CLP, it will be fulfilled. In the case of the toxicology testing, for the molecules that we are going to use, it will be evaluated to be sure, of course, of their fulfillment, but it is not foreseen that a new substance, it will be a new molecule, it will be developed non-existing nowadays. So the need of the consideration of a non-registered molecule is not foreseen, but in case that this could be the case, of course, all the testing required for their registration as a new substance, it will be considered. All the tests related to allergenicity, migration, skin oral contact risk, it will be evaluated for some applications, of course, for the ones that have sense to be applied. This is the case for some of the consumer goods that we have identified as applications, and we will study any potential risk related to the formation of these nano and microplastics. And related to ecotoxicological evaluation, of course, both the repolymers but also the building blocks, it will be analyzed. How we are going to apply different tests. Here you can see that for sure standardized toxicological methods based on REACH and the OECD methods, ETC, it will be applied, but also we are going to apply, because they are already developed by one of our partners, MATEM, some new approach methods. It will be applied for endocrine disruptive testing. So the testing, it will be applied also to conventional plasticizers and additives identified from the market with these new approach methods to measure the toxicity in fish embryo and the endocrine disruptor effect of them. And it will be used as reference for the materials that we are developing. Other important thing to be considered is the comparison related to the analysis and preliminary toxicological screening of the building blocks and the polymers related to the selection of them based on rapid acute toxicological testing, but also some prolonged testing for chronic effects. It will be evaluated. So here in this slide, you can see, for example, an example of some of the methods that we are going to apply on this sense, considering the duration of them from the shorter for acute toxicity to the chronic ones. And the ones that you can see in green are these ones that we can say or that we can have called as new approach methods, because go beyond the state of the art and have been developed by our consortium partners. Finally, in this part of the methodology, of course, we have to consider the assessment of the 3 pillars of the sustainability that we have mentioned. And we have based the methodology to fulfill with the safety and sustainable by design mainly in the recommendation published at the end of last year, this one that you can see here, in which we have considered also information related to the communication CC7, in which it was defined that this safety and sustainable by design framework should have developed. So in this hierarchy that you can see in this graph, for example, we can see that the elimination and the remediation are the first objectives, the minimization and the control of any effect on humans and environment, and the development of safe and sustainable chemicals, which is one of the main aims of our project. We have evaluated the most critical additives included in the inventory. As I have mentioned at the beginning, there are a lot of information, but mainly they are focused on big families, and sometimes if you don't know which substance are you looking information for a specific substance, is complicated to know if a specific plasticizer or lubricant, or which plasticizer, for example, is less hazardous than other, because you have to look information substance by substance, okay? And in the plastic additives initiative, which has been the base of this ECA inventory, as you can see here, it's true that we can find a lot of information related to different families of additives, but there are hundreds, or we can say better, thousands of families of additives in the plastic industry. So as much information as we can achieve related to the most hazardous substances in this sense to be replaced, it will be better, and this is one of our aims. So we have analyzed in depth the ECA inventory and this plastic additives initiative that I have just shown in the previous slide, and we have seen or we have isolated some interesting information related with key aspects and gaps. And in this sense, we have identified the most relevant strategies to be carried out and to try to achieve as much interesting information as possible for this inventory of plastics and this safety and sustainable by design approach. So, for example, here you can see some information. We are not going into detail, but you can see that 418 additives have been included in this initiative, but 58% were not under regulatory scrutiny until REACH or CLP. It is foreseen that along the next years, this 58% it will be increased. We are sure of this, but it's just an interesting value to be known that there are a lot of additives that for the moment are not below this scrutiny. 11% remain without any information related to their function, for example. We can say also that most critical additives are compared relative to their release potential. Of course, this is very important. But they are based only in these 4 aspects: the molecular weight, the vapor pressure, the water solubility, and the log, the partition coefficient between N-hexanol and water, which is quite related also with the water solubility. So we can say that with these 4 parameters, this release potential has been defined. And in this sense, the most critical additives, and there are a lot of additional parameters that should be considered, and that for sure will supply a more complete knowledge of the hazardous and the critical additives that has to be considered. So another important thing is, for example, that if you read this practical guide, you can see that some uses are not covered, as compounding, installation, maintenance, operations with plastic waste, exposure to microplastics, etc. And finally, of course, these practical guidelines have been based on the migration modeling based on the Joint Research Center, which has a lot of information for food packaging applications, for example, but even for food packaging applications, there is a lack of information for several polymers, and of course, for other polymers that are not used on food contact materials. So our strategies are based on direct contact with companies, associations, etc., including our advisory board partners, to identify the most critical additives with them and the exposure scenarios. We have been made, and we will continue working on the search of relevant information in toxicity and ecotoxicity databases. We are making a scientific bibliography research. We will study in depth the food contact regulation related to non-intentionally added substances, because it contains a lot of information. But of course, these, as I have mentioned, are very focused on this type of applications, but it will be a good base for other applications too. We are going to use also software and CUSAR models, and with the expertise of our toxicologists and ecotoxicologists, we will focus our attention in the main key points, identifying the gaps and the most relevant criteria, of course, complying with REACH and CLP regulations. Here you can see the regulatory framework and the standards that we are going and that we have work on them related to the main 3 sectors of applications. And for example, just to show you a picture of what we are doing related to the inventory of plastics, we have mentioned at the beginning, I don't know if you are aware of this, but our main is not to use additives in our formulations, and in case that we use additives, they should be bio-based if possible, and for sure safe additives. So we are analyzing the main groups of polymer additives related to the products that we are going to develop, and the most critical substance of potential concern in these polymers. Our principles underpinning the safety and sustainable by design concept are these ones: define a hierarchy to put safety first, to avoid any replacement in the future, in the close future at least, define cut-off criteria to stimulate the research. And so for this reason, the design of the chemicals and materials, it will be based on this and on the requirements and the regulations related. We are working in an iterative way, as I have mentioned, and we are trying to reach as much information as possible related to adverse effects. We are working on a communication strategy also. This is today is an example of this, and we promote the use of this framework in every event or with the policymakers and with the industry with which we are related. Our focus has been put in this recommendation that was published at the end of the year. So in our case, as we are going to develop new chemicals and materials, in our case is more a design and not a redesign concept, although the redesign it will be carried out along the progress of the project, for sure, improving as much as possible all the developments. And the stages 1, 2 that are composed by different steps, as you have mentioned in previous tasks. I think that, as you have explained it very well, are more or less the same. Just to mention that in our case, the molecular design is the base for the design stage, for the stage 1, and the process design and the product design, it will be, of course, also considered, but in a lower effort, we can say, because the molecular design for us is the basis for all the developments that we are going to carry out. We are including all the part of the material efficiency in every process that we develop along all the value chain. We consider the material efficiency. As I have mentioned, reusability and recycling are the main aims as the preference end of life, to reduce waste, maximize yields in every process. Of course, the avoidance of the use of hazardous chemicals or materials, no additive that involves any hazard properties should be included in our developments. The energy efficiency is considered also. For example, reactive extrusion, it will be used in case of possibility, if it's feasible, because in reactive extrusion you can be considered as a polymerization route between the greener technologies, because the avoidance or the reduction of solvents, minimizing the timings of reactions, etc. We consider that purification steps should be as less as possible. If we can reduce it, better. If we can reduce the solvents use volumes, of course, better too. The use of renewable sources or waste valorization, you know, that is one of the concepts that we have considered, and minimize emissions related to these solvents that we are going to avoid. If water is possible, of course, it will be the preferable solvent, and in case of solid state polymerizations, it will be the process is preferable in this sense also. And in the end of life, the nano and microplastic control is very relevant for us, but we will include also spectral analysis for sorting, design for the construction, etc. So in all these 4 steps in the stage 2, we are going to focus our attention and our approach, and related to the LCA, LCC, and social LCA, of course, it will be addressed also considering this responsible research and innovation that sometimes is forgotten, and that we think that are concepts very relevant too. And this is all.
Hello, everyone. We are getting ready again. I will say let's wait 1 minute to be sure that everyone is back at their place and that the speaker will be on stage. I hope you had a nice lunch break. In the meantime, I will ask the last project, so the speakers from Estella project, if they want, they can start already sharing their screen, and then we will make it full screen for everyone from SEWA. Okay, that's perfect.
Can you see our screen and can you hear us?
Yes.
Yeah.
Okay.
Okay. So let's have a look. People are back, it seems. Okay. Then so for welcome back everyone. For the last project today, describing the SSBD methodology is project Estella. There will be 4 speakers from project Estella: Alicia Rodriguez Carrascal and Maria Asensio from SIDO. Okay, thank you. Sara Gil Guerrero from Idne, and Jens Olsen from ECRT. So I will now leave you the floor, and we can get back to our business. We don't.
Ups. ¿Qué es esto? No.
Se ve bien. It's okay.
Sí, pero no es lo que quiero. A moment. I don't know. Es que, no, a moment. Sorry. Pero ¿por qué no me deja? Vale.
And today my microphone is working.
Okay, perfect. Okay. Okay, now, sorry. Hello, my name is Alicia Rodriguez and I work for FIDAO. We are the coordinators of Estella project.
Sorry, we still see the Microsoft PowerPoint not presentation. So let me just show you when you click on share screen, you have 3 options. You have to go the one that is most convenient to show the whole screen, and it's the 3rd option. So if you see there are
Okay.
So in this way we will see the screen you are presenting.
Now? Yes.
It's loading. Now we see, yes, basically the light, and perfect. That's perfect. Thank you.
Okay, no, thank you. So, okay, as I said, we are the coordinator of Estella project, and Estella is the acronym of our project, and the whole title is Design of Bio-Based Thermoset Polymer with Recycling Capability by Dynamic Bonds for Biocomposite Manufacturing. This project owns to the same topic than the rest of the projects that have been presented today in this workshop. Our total budget is almost 5 million. We started with our project in June of last year and will end at the end of 2025. In Estella project, we work 13 partners from 9 different countries from Europe, and in this consortium, we have universities, institutes, research centers, companies, etc. Therefore, we are a solid and complete consortium that we work together in order to achieve our objective. And what is this objective? The objective of our project is to increase the sustainability of thermosetting epoxy composites. To do that, we will work on the whole value chain of the materials, starting with the definition of the setup conditions and the tools in order to be able to have a final recyclable and sustainable material. In this chain, we work in the design of the composites. The composites are composed by thermoset matrices that use can bonds and natural fibers. These fibers are cellulose and hemp. Then we also work in the development and definition of the best manufacturing process for these novel composites. On one hand, we will work with continuous fibers, and in this case, we will manufacture a final prototype for the export sector. And for this, we have chosen to make a platform for a scooter device. And on the other hand, when we work with discontinuous fiber, we'll focus on the construction sector. And for this, we'll make a windows frame. Then, to close and to complete this chain, we will work in the best composite recycling process. To do that, we'll analyze 3 different techniques: the mechanical recycling, the chemical recycling, and the biological recycling techniques. And once we have done all these activities, we'll be able to recover the matrices and the fibers totally. So with this, we have complete our process cycle. To do this, we'll work in 8 different work packages. You can see here the scheme of our work package distribution. You can see that all of them are interconnected, and then we'll focus on each of these work packages when we explain our methodology. But now, if we focus in the SSBD framework, that is our today objective, as we have seen previously in other presentations, the SSBD can be divided in 4 stages: the design and redesign, the production, the use, and the end of life. If now we compare both schemes, the schemes of the SSBD framework and the Estella scheme, we can see that they are totally comparable. So our strategy is totally in line with the SSBD strategy. So now we'll focus in explain you our SSBD methodology. Sorry, I don't know. Sorry. If we focus in the 4 steps of the SSBD framework, and now we started with the design stage. In Estella project, related with these states, we'll work in the development of the materials. On one hand, in the development of the matrices, and on the other hand, in the obtaining of the fibers. And this will be done in work package 1 and will work package 2. With this, we are looking for safe and sustainable materials. But on the other hand, related with the design, we work also in the LCA, in the social LCA, and in the LCC, and it will be happen on work package C. If we continue with the production stage of the SSBD framework, and we look to our project, we can see that in work package 3, we are working in the design and manufacturing of our composites, and always considering the most efficient recycling technique for the composite reprocessing. We continue with the use state, and for that, in work package 5, we will carry out a complete safety and exposure assessment. And if we end this cycle focusing in the end of life, in Estella project, as I said, we'll work in the recycling of the composites and the matrices, and this will happen in work package 1 and 4. And with this, we'll have covered all the cycle of the SSBD. But also, we cover cross-cutting aspect. And in work package 7, we'll work in the dissemination, training, and skill dissemination of our results and of our developments. On the other hand, in work package 6, we'll focus in the development of the economical and innovative business models. But as we saw previously in the previous slide, all our work packages are interconnected. So at the end, all Estella project will work at a whole with the objective to comply with the SSBD objectives. And now we would like to show you our strategy more deeply. And firstly, we'll start with the presentation of the main SSBD actors in our project. As we just have seen, all the work packages of Estella project will work in the SSBD strategy, but we have 2 work packages totally focused on this. One is work package 5, that is on safety assessment, and the other one is work package 6, that is based in LCA, LCC, and sustainable assessment. Now, I'll give the floor to my colleagues, Sarah Hill and Jens Olsen, and they will explain you deeply this SSBD approach. So I think it's best that Sarah share her screen.
Yeah, I think that now you can hear me. Yeah.
We hear you, but we don't see your screen.
Yeah, actually I'm sharing. I don't know if you can
Yes.
see it now.
This is fine.
Okay.
If you just
Okay,
yes.
so thank you very much, Alicia, for introducing me. As she mentioned, my name is Sarah Hill, and I work in IDNR. We are a company for the development and application of computational models and tools, and we are now leading some tasks of the safety assessment in the work package 5 of Estella project. Probably as most of projects that has introduced their projects today, we defined the task of the work package 5 prior to the last release of the recommendation of the SSBD approach. So a lot of our efforts within the project has been trying to adapt our task to the current definition of the framework. And today I'm going to try to introduce you how we have adapt our task to a hierarchically stepwise approach that guide the decision making of different work packages regarding the safety dimension, and also which of the tools and strategies and methodologies that has been recommended within the Commission and projects related with the framework that we have introduced in our task. So this work package 5, as said, is devoted to the safety and assessment and involves 3 tasks: the toxicity evaluation of the degradation products and components of the development materials, the exposure of human and biodiversity to these materials and the degradation products, and finally the collection of this data together to develop a risk assessment that will guide the safety of the products. And for that, we will use cutting-edge computational methodologies such as new approach methodologies under integrated approaches to testing and assessment. And we have adapted this work package in order to fulfill this hierarchically stepwise approach proposed by the Commission that lies in step 1 to step 3 of the framework that covers the safety dimension. For that aim, we have connect each of the tasks with different work package in which we consider that is relevant. The assessment for the hazard. We will perform in silico prediction models for human toxicity and ecotoxicity that will connect with the work package 2 of components and formulation, and the work package 4 with the degradation products of the recyclability of the materials that, as Alicia mentioned, it's really relevant for our project to recover the products, and then it will be really interesting to analyze the byproducts of the recycling process, and also the exposure in which we will evaluate the production and manufacture approaches that are developed within the product and related with the workers and with the workstation, but also the exposure of human and environmental targets to this. And for that, we have, with this information, we will perform the risk assessment. Also, with some of the latest recommendations from PARC and IRIS. Okay, so for the hazard, as said, we are going to perform model-based evaluation of human targets and environmental toxicity. For the human targets, we will really consider the application of the materials. For example, as Alicia mentioned, we are going to focus in some value chain of the Windows frame development. So in that, the skin sensitization of a human will be a really good thing to evaluate, but also the non-target environmental endpoints will be evaluated. So model species for the different environmental compartments will be assessed. And we will try to adhere to the recommendation of software platform and resources from PARC. So we will rely in trustful platforms such as QSR Toolbox, Vega, and databases that are curated, such as the EPA, the Norman, the EFSA. However, as we are not with the materials, and I think that Belén from Repurpose already mentioned that there are a lot of data gaps even in the regulated formulations and compounds. So in order to fill these data gaps, we are going to perform specific models that will be based in QSAR models with quantum descriptors when not other data is available, or even adverse outcome pathways for those compounds in which the toxicity mechanisms are not properly defined. That will be performed not only for filling the gap for those compounds that has data gaps in the REACH or ECA regulation, but also those that are not indeed regulated yet. Then for the exposure, it will be really important to evaluate both two types of exposure: the occupational exposure that will be really related with the work package 3, in which we will evaluate the manufacturing process regarding also the source of risk and the potential hazard to the workers, and also the environmental exposure, which will be really connected with work package 5 for in terms of the byproducts and the degradation products that can reach the ecosystem. And for that, we will, together with the partners of these work packages, we will identify the source of risk. We will characterize the different pathways from which these compounds can be available to the targets, and we will estimate the exposure levels based on a predefined criteria. We will define a low, medium, and high risk of exposure, and we will define our models considering this. And finally, for the environmental targets, we will also evaluate the bioaccumulation, persistence, and toxicity of these degradation products by performing modeling of dispersion, transport, and fate. And also, we will gather information about the potential degradability from partners in the work package 4, but also the potential biodegradability of the degradation products or byproducts of this recycling process. Then, by integrating the toxicity, we will be able to perform some models in tools that are accepted by the Commission, such as SETOC, about this exposure, and then about the risk assessment. I would like to explain you how we are going to do this hierarchically, following the recommendation of the Commission from step 1 to step 3. The step 1 will be the hazard assessment of the chemicals and materials, and this will be really relevant for the work package 2, in which the design phase of the thermoset polymer with CAN and the obtention of natural fibers is going to be done. So for that, although this task has not yet started, we have already predefined some criteria regarding safety with the creation of an inventory, collecting all the hazardous compounds and the candidates for substitution that are commonly used in the plastic industry, but also we will take that as a guide for as a criteria for taking them off of our formulation, but also we have created an inventory with the formulations with a promising alternative of compound solvents that are mostly bio-based or non-harmful, and that has served as an input for work package 2. Currently, now they are working in the development of the thermoset polymers, and we have prepared some questionnaires for the partners that will serve as input for step 1, the hazard assessment, in which we will perform the in silico model and different data mining process for gathering the intrinsic hazard properties, not only toxicity, but others such as volatility, inflammability, all these kind, and will serve as a guideline for task 2.4 and task 2.9, in which the selection and production of the epoxy resin formulation will be performed, so as the natural fibers. Once the design phase is covered, in the production, we will evaluate the human health and safety aspect of this stage, and is closely related with work package 3, where the manufactured composites process is defined. Again, a pre-criteria has been defined considering the requirements of the composite manufacturing. And here we want to increase these requirements not only to the efficiency of the process, but also to the safety of the process. And also with my colleague, probably, with the sustainability of the process economically and environmentally. And then the results regarding the exposure evaluation of the workers at the workplace will serve also as a guideline for the work package 3. Finally, in step 3 of the safety assessment, we will evaluate the environmental aspects and the human aspects considered in the application phase. Here we have integrated both the use and the end of life of the product. And the use, we don't have an explicit work package that deals with the use, but we have already defined some pre-criteria in which the requirements for future application is integrated. And here is where we will evaluate the hazard and exposure regarding the potential application of the products. Finally, for the end of life, this is a really significant, relevant work package in the project. So we will take care of evaluating the degradation and byproducts of this recycling with both hazard evaluation and exposure in environmental compartments. And we will take into consideration the target recyclability that has been predefined in order to make some guidelines for the choice of one or other recycling method between mechanical, chemical, and biological. Altogether, we will give an overall perspective of the safety of the products in the different stages of its life cycle, and we will try to support the framework with the efforts made collecting data, as we will try, when it's possible, to share it following the FAIR principles, but also we will try to adhere to the latest recommendation that comes in regarding the safety dimension. And now I let you with my colleague Jen Olsen, that is responsible of the sustainability part. Thank you very much.
But I do suggest that you handle the slides, because I don't have the...
Okay, no worry, I will share them.
Yeah, you can just... I think you have all the slides. Might keep you on it.
Okay, so just let me know when you want to switch.
Yeah, that's fine. Yeah, we need to do the total assessment of LCA, LCC, and the real issue we have when we do these assessment, the economic assessment, the social assessment, and the LCA, LCC, is that at this level, and it seems to be at the level of most of these projects. These are all research projects, and most of the materials are made in laboratories. And when we are talking about economic life cost, lab results are really of not much interest. Social, well, we are, of course, living human beings in the laboratories, but we are not the real ones who do the production. And environmental, LCA, LCC, and safety, well, our safety might be important, and the way we do things might be important, but the real thing is the real production. Let's take the next. Sarah, will you switch? Thank you. We do the analysis as good as we can. The life cycle assessment is an assessment that mostly focus on the CO2 emission of the products, and CO2 emissions of the lab scale production is of no interest. We very often have to go and look at basically find products that are alike what we look at. and we cannot really. It's often that the databases that we use for the analysis are not sufficient to find the correct data. We need basically to construct data, and therefore it's difficult task. So these analyst works, we have the plan for it, but we do not have the work in progress, for the simple reason that the ingredients in the products that we produce and intend to produce are not defined yet. Until they're defined, we cannot make these analyses. But what we can do is, of course, to prepare so the analysis, the software and the tools are available and ready to be used. And what we can do, and what I find to be very important, was Sarah expressed, is we can analyze the hazards in connection with the products and the recyclability of the products from day one, so we avoid the hazards that really should be avoided before we start to make too many steps. Let's take the next one, Sarah. And the LCA is done in accordance with the ISO standards. It's the CO2 impact that we measure. We make calculations. You don't really know it, but calculations on LCA are done based on available databases and database values. And you often get wrong values, and you often get wrong values, especially when you go from the small non-productive things to real production. So we have to make a number of assumptions to make a picture that is more correct than nothing. We initially go from cradle to gate, which is we'll measure from, we start from cradle to basically to recycling, but the recycling in this project is not recycling. It's basically to be recycling and reuse, and it has to be recycling complete to complete the circle, so we can take things apart and use them again, all of it. We work with different kind of recycling methods. The mechanical recycling of composite is a tough one to reuse because the fibers, if you do a mechanical recycling, is usually destroyed. But anyway, we'll do the first we'll measure what cradle to gate, and after that we'll take a good hard look at the recycling and see if we can get to the full circle. This is not an easy task. I say it here. I know it's important we do it from design base to the next, but to make the full circle of recycling is a tough one when it comes to composites, for the simple reason: how do we split them in a way we can reuse the materials and the ingredients? That is a tough one. Especially, we have requirements to the use of the composite. It has to be strong enough to be used in facilities, and in order to be strong enough, then you really are creating a tough situation when you need to recycle it. Anyway, this is what we have been dealing with for a long time, and we haven't solved it completely yet, but we'll move on. Okay, Sarah? Yes, and that's, I think we pass on now to Alicia.
Yeah, Alicia, do you want me to stop sharing and you continue sharing?
Yes, I can share my computer.
And thank you for your help, Sarah.
Okay, so once my colleagues have presented the tools, now to end our today presentation, we will show you how we integrate these tools in our project. To do that, I give the floor to my colleague Maria Asensio.
Hello, as my colleagues explained before, the assessment of SSBD in the Estella project has following these steps: the design, the production and use, and the end of life. For that, we have realized an SSBD activity, establishing in each of these stages the inputs, taking in account the SSBD objectives, the hotspots, using the tools explained previously by James and Sarah, and the established requirements. Also, we establish the outputs of each phases and the final results. Okay, the first step is the design. For the design, we have identified the priorities for the substitution of plastic additives in the matrix, in the fibers, in all the materials used in the Estella project, and also we study what additives are in the future application, in the construction, in the window frame, and in the scooter platform. For this, as I said before, the SSBD inputs in this phase are the source of the material, the selection of the additives, the type of the can, looking for the additives to be safe and sustainable, also alternatives, and the type of the fibers, looking for natural fibers. Well, what are the hotspots of this first step of the design? The hotspots we have identified are the formation of reversible epoxy resins with cans. In this first step hotspot, we have an input from the work package 1. We have developed yet this deliverable 1.1 when we have identified the priorities for substitute the plastic additives for the epoxy resins. The second hotspot is the sustainable and recyclable blends of fibers with epoxy resins. Also, we have inputs from this deliverable and activity. The test of recyclability of the materials developed and the test of biodegradability of the materials developed. What happens if these hotspots doesn't work or doesn't comply the objectives or the range of the values? That we have to redesign in these inputs. What happens if we comply these hotspots? We have some outputs of SSBD in this first step of design. We will have recyclable biocomposites that we will work in the recyclability in work package 4, and biodegradable biocomposites that will try the biodegradable in the work package 5. For the second phase, the production and use, we have defined the materials requirements for the composite manufacturing and study the composite requirements according to the future application, the window frame and the scooter platform. The inputs in this phase are the material previously designed, complying the sustainable supply of primary raw materials. The process in this step is important to look for processes, clean, green, and efficient production processes, and the product that must comply the functionality and the performance. For the functionality and the performance, we have carried out an activity looking for the properties that the future application must comply, such as properties, such as mechanical properties, viscosity, or etc. What are the hotspots in this phase? We have the first new sustainable materials with optimal viscosity for out-of-autoclave processes. We have to look for that materials not also sustainable and safety, but also that these materials designs must be processed in a real industrial. So these materials must comply functionality and performance for the processes. Also, the second hotspot in this phase is that the processes look for develop the material, the composites, the final composites, and the application must be energy consume the energy lower than the processes currently used for develop composites in this application, that are the autoclave processes.
Let me just push in here, if okay, that this is one of the issues that we have, that this has to be a real life energy consumption. It has to be a real production energy consumption we are assessing here, and I just want to throw this in.
Yes, thank you. Thank you. And the last one, we have to comply the properties comparable to the application with fossil and non-recyclable materials. We study also in previous activities in work package 1 what properties must comply with these new materials to develop composites to manufacture the future applications. If we don't comply these hotspots, we have to rethink also the material in the process, also in the design of the products, always thinking in the design in these phases. And if these hotspots are okay, we will have SSBD outputs for the next steps, such as one prototype feasible, one production process efficient, and one prototype durable and complying with the properties that the application must comply. The last part, the last phase, is the end of life. We have defined the recyclability target conditions also in the first steps of the Estella projects. And the inputs for these states are the materials fabricated or manufactured in the previous step, the biocomposites with the resins designs and the fiber design. And these materials must comply in this phase the recyclability. For this, as I said before, we study the target conditions for the recycling, the enzymes for the biological recyclings, the solvents for the chemical recyclings, and alternative recycling methods as a heat and radiation. The hot spots for this end of life are that we should recover materials with quality properties for revalorization. We have to make an environmental analysis of the recycling processes, looking for the best option for recycling these final products or biocomposite materials. And with all of this information, we have to decide and select the most efficient recycling techniques.
And let me just throw in here as one more thing. We discussed earlier the hazards and the with the environmental for people who works with it, and it is our experience that during recycling processes we must be very much aware that we don't introduce new hazards for the work environment. We discussed it earlier, and so I just want to mention that this is an important task when we do the recycling, and that it's another little, that the environmental analysis hotspot is as well for the work environment and for the new introduction of other hazardous products. Don't you agree, Sarah?
Yeah, sure. That is one of the main. Yeah. Actually, yeah. That will be one of the main keys of the end of life, and also evaluate the potential of the biodegradative of the different environmental compartments.
Yep.
We try to comply all the objectives of the SSBD as my colleague said. And if not, we again have to rethink and redesign also the recycling processes. And if these hotspots are okay, we will have SSBD outputs. We will have a secondary raw materials with quality and sustainable and safety objectives, okay? And we will have a recycling process scaled also in the Estella project. To finalize, we want to say in Estella project we want to achieve a lot of objectives such as achieve a recyclable biocomposites, biodegradable biocomposites, an efficient production process, a prototype feasible and durable, and to obtain secondary raw materials and a recycling process scaled to summarize the objectives of Estella. But always...
Alicia?
Yeah.
Should we succeed in hitting all those goals, we are going to have a big party, because those are large goals to have in a one project.
Yes, for that we have we want to say in this slide we have worked together with and collaborate partners from Estella and partners from other projects in workshops like this, trying to best in SSPD objectives, in the design of new materials, new processes of manufacturing or processes of recycling, always trying to achieve a sustainable and safety materials. Is that for all? Thank you for your attention.
Okay, thank you for this very nice presentation of your methodology and the overall project. So we have actually 10 minutes for the question. I invite you again to use the question tool if you have any question for the Estella project. I have a question actually that maybe I missed this information. The need to have two work packages, one focused on sustainability and another one focused on safety, is that mainly organizational or better institutional because the partners are separated, or you can streamline better your work in this way? Because finally, the two lights of the traffic lights that you've shown, I think that one comes from one work package and the other from the other one.
Well, sustainability is one thing, and we find that it's pretty efficient to split it the way we've done it, and I find that the split between the valuation of hazards and toxicology and between the sustainability, I think it's a fair split, because I think we have different knowledge and different knowledge base that we draw from. So I find this to be a pretty efficient way of doing it. But I think the reason behind it is probably because of our different points of reference.
Okay, thank you. Thank you for your clear and exhaustive answer. So, are there any questions? Eventually, I invite the other speakers, if they have a question, they also have the chance of unmute themselves and ask it directly. This is not true for the rest of the audience, but well, okay. Then if this is not the case, I thank you again, all the Estella project members to give this nice overview of the project and their method and their methodology. And I invite everyone to go back on Menti. Let me share. So you have to go on menti.com. Let me share again.
But let me just say, if we make the successes that we anticipate or hope for, we will invite you all to the party.
Then I look forward. I love party. Okay, so I invite you all to go again on Menti, and I will soon share my screen. Am I? So the code, maybe, I don't know if you now see this is the last slide we were in. So you have to join us at menti.com and use the following code, 199-62319. So let's, okay, actually this question was supposed to be this morning, but let's say what this is free answer. You have no limits. What was your interest in this workshop, or why you aim to participate in here? I hope there will be more than I was forced by my coordinator. Okay. Okay, we have just 10 answers, and we are supposed to be online at the moment, roughly 60 people.
43.
43. Okay, so let's see what are the SSBD researching project. Learn about the experience of the research teams of the SSBD case studies, know more about other projects, understand the SSBD framework implementation, learn about SSBD coordination, learns what other projects are doing, establish a framework in the SSBD European project. So I think that finally, I mean, of course, the focus was the SSBD framework, but looking at the reply that you are giving, it seems that there was room for, let's say, not simply learn from each other, but also try to see if we can go to a common direction. How to deal with 3 aspects: uncertainty, lack of data, KPIs. Okay, we have 21 responses so far. Let's wait another couple of minutes. Maybe there are people that are either shy or, well, the reply might be already in the cloud, in this word cloud we are already seeing. But in that case, even if it is exactly the same formulation, or if it is a very similar formulation, just write it down. This allows us to understand what was the interest of the audience, together with this background and the follow-up questions that is going to be, we might understand better what might come next to this workshop. Okay, it seems that we have leveled off to 21 response. Okay, let's move then to our next question. So, what is the technology readiness level of the application product you are actually working on? And for those who are not familiar with Dragon Ball, that's what the three images come from. Okay, 17, 18. See if we can reach. So anyway, it seems that we are relatively, I mean, there is quite some interest in the intermediate TRL, so open moving forward to their commercialization, industrialization of the product that they, or application that they are proposing. But also we see that there is none already, of course, a tight TRL at the moment, and a participation anyway on people working at very low TRL, which is the case for some of our projects. Okay, thank you. Okay, it seems okay. 14 people between TRL 4 and 6, 3 people at TRL 1 to 3, and just one replied working on any development. Well, this is the scope of this workshop is also that of letting people understand what SSBD is and how European projects are contributing to the implementation of this SSBD framework. Okay, let's wait still a few more minutes, a few more seconds, I would say. Seems that we have no more reply, so let's go to the next question then. So before the workshop, what was your knowledge about SSBD in general as a topic? Okay, maybe all our experts have left already. Or maybe since they, okay, more and more beginner, but this is good. This is as a starting point for a first workshop that was mostly also our target. I will not expect all the experts from JRC to come and follow what we are doing about what they said already. But anyway, lots of people doing implementation, so from beginner to intermediate. Okay. Have you replied? Okay, so here at SEOA we are replying as well. We have leveled off to 21 answers. Let's then move to the next question. What do you think about this workshop? Was the information useful to you, or did it satisfy your expectation? Well, overall it went very well. Yet we have reached the cap limit of 21 answers, so I think that we can move forward to the next question. And do you think there is any topic that should have been improved, or that we should have given more details about something specific? Again, feel free to add any comment, suggestion. The only rule here will be just be polite. Okay, we have methodologies. Social and economic SSBD implementation. More practical approaches should have been shown, mainly for the results report and interpretation. More details on the practical assessment, even if still in progress, to understand limitation and real case study issues. How to manage scaling up. Okay, it seems that there are a lot of suggestions, and thank you very much. Just as a reminder, I know that lots of people might have wanted to see results on about the case studies as well, but I want to remember that all these projects just started. They are 25% of their project lifetime, roughly, and so now we are starting collecting results. Thank you anyway for this feedback. For sure, it will be very helpful eventually for the organization, possibly for the organization of other workshops. But this workshop was mostly focused on showing what our methodology, our vision at large about our implementation. Main result once the project are more advanced. More discussion on SCC and social life cycle assessment. Use phase of the products, yes, that will come, hopefully will come later. In the case of SURPASS anyway, we will reach low intermediate level of TRL, so the finite product and the final product will still be, let's say, far away, but yes, that can be also a suggestion. A more stringent format where the SSBD goals were clearly marked out, and then we would have done this in a shorter session. Okay, thank you. There are no other replies at the moment, so I'll move to the next slide. And now we go specific to the next workshop. What would you like us to treat? And again, this is with this question help us prioritizing what to do next. So even if you see your reply already somewhere, give it again. It will give more weight to that item. example for data collection. Inventory of plastics. Synergies on the inventory, best practices for how to go about this SPP. Data templates. Data collection and templates, data collection. The key redesign recommendation that have been identified. Tools and digital infrastructure presentation. Most important KPI to cover. Again, we have leveled off around 15 responses. Let's it seems so far that the data collection, data templates, data treatment is the tool that have more votes at the moment. It's not that the other will not be considered. As I said, this is just for prioritizing and understanding what is the interest the audience has. But this is the moment for all those who want to hear about something else to vote just on that one. And okay. Any auto-defined criteria values. Let's wait another minute, and then anyway, you can send us this feedback continually. You can contact us through the website of the Four Sister project, and possibly in the next week you will also receive a satisfaction questionnaire in which we will put our email address so that you can reach directly to us if you have, again, any specific question, or if you want to raise a point, and that might come even later. I mean, I understand that maybe you need to digest, let's say, the information and think about what actually you would like to have next in a future workshop. So, okay, we have 17 scaling up issues is taking that as well. LCA and LCC, how to approach monetization of environmental externalities in ELCC. Tools and digital infrastructure. So tools is gaining 19 responses. Yeah. I think how to elaborate social LCA based on SSPT. Well, okay, we are not getting any other response at the moment, so that was it. Thank you all for your collaboration, and I want to thank again all our sister Project Redondo, Project Repurpose, and Estella for all the help they had and the discussion that we had in these months and on how to organize and what would have been the topic of this workshop. I want to thank all of you for taking your time and participating. I would say there was a very active participation, both at the, I mean, especially at the first interactive session. But also I've seen that in the chat you have been interacting with each other, giving a hand to help yourself and or simply to know when things were going. I want to thank finally also the equipe here at COA, which has been very, very involved in the organization of this of the workshop, in the definition of the content. And if you have any question, well, I will invite the speakers to, if they want to say something, even just if they want to cheer the audience, just to open their microphone and just speak.
Well, I like to say that I find this to have been a better session than I expected. We were actually able to learn something from different projects, and I think that you all did pretty well. And I think when we look at each other, then we should evaluate how to make our own project relevant for the people that are not really involved in the project, but and what is it that we want from the others. We want to learn the smart things. We can't know everything about the other projects. We want to learn the smart things, and to some extent we succeeded in that today, and that was good. So I think it was valuable, and we are all little fumbling along a little bit. We don't know exactly where we're going. It's difficult to do redesign of product that we use. We make a product, we bring it to certain, and we need to bring it back and redesign it. That's not easy. So I think we need to learn from each other if we can, because I think it's a very ambitious project that the EU has put on our table, and it's not an easy task. And we all try, we fumble a little bit, but I think we all learn a little bit today.
Thank you, Jens. I don't know, Diogo or Zofia, you want to share a few words with the audience?
Yeah, thanks a lot for organizing this workshop, and I think we have a longer journey ahead of us, all the projects, and I think it will be definitely interesting to find the ways how we can collaborate in this very unknown new field in the future, and I think we are looking forward to that very much.
We'll be in touch very soon then, I guess.
Yeah, I also think it was a great new workshop, and a follow-up for this workshop would be very interesting, covering the tools and the assessments that we will conduct down the line and provide those results. I think there's much to learn, and as Jen said, if we achieve these objectives, it will be really, really important for all the projects.
Belen, Yvonne, you want Alicia? Maybe in this order or in no? fine for Belen.
Just to say thank you again, all the presenters, and for sure Andrea team for the organization. And it has been a pleasure to be with all of you. I think that all of us have learned a bit more about this new concept that we have to include more and more in the next and very close future and developments in all the new. Sorry, Andrea, are you saying something?
No. It's
sorry.
We are a few people in the same room, so even.
Okay. Just this.
For our side, thank you again for the organization, and thank you all of you, the rest of the projects, my colleagues. I think it has been a good first workshop. I think it's a good opportunity to put in common our strategies and our worries about this new framework. And it's great to have the opportunity to work with projects that are in line with our project and know that we have the support of you in our SSBD future activities. So thank you, and we'll work together in the future.
Okay, last but not least, I would like to hear from Yvonne and Sebastian Artus, the two work package leader of the SSBD work package in SURPASS.
Yeah.
Go ahead, please.
Go ahead, Yvonne.
Yeah, thank you. I agree with what's been said already. It was a really good workshop, and it was good to see what the other projects are doing and the issues they're struggling with. And I think really we can learn a lot from each other also during the process. So it would be really good if we can collaborate along the way and see what we all encounter.
Thanks, Ivan. Yeah, I think it's very interesting, and as it showed at the beginning, sustainability is a cross-skill area, and we have to work together, and some people in some different field of work have to learn to work together to provide this integrated approach, and it's one of the challenge. And workshop like this, I think, allow to exchange and cross our knowledge.
Well,
Andrea?
Yes.
Do you guys see the pictures behind me?
Yes.
This is real recycling. These are my two daughters.
Oh.
Thank you.
Thank you again to everyone to the speakers and the audience for participating to this workshop, and stay tuned on our social media and or subscribe to our newsletter for news and upcoming events. Bye everyone.
Thank you. Bye.
Thank you. Bye bye.
Bye.
Bye.